Hi, good morning, ladies and gentlemen. Hi, so good morning, ladies and gentlemen, and welcome to the first promote event of the EUROCONTROL Innovation Initiative. Thanks for joining. My name is Laurent Renou, Head of EUROCONTROL Experimental Center located in Brétigny, south of Paris, and Head of Air Transport Innovation. So today it will be the opportunity to present you the result of the project of our first cycle and to launch the second batch of innovation project. But before getting into the heart of our promote event, I'm delighted to give the floor to our Director General, Mr. Eamon Brennan, that will officially launch this innovation initiative. So Eamon, the floor is yours.
Good morning, Laurent, and thank you to everybody who's participating today. It's really great to see such a distinguished audience, and it's really good to see the result of the phase one of this initiative coming to fruition. So, Laurent, I think it's always important that we just reflect on the difficult situation where we find ourselves today with COVID. You know, we have not made as much progress in Europe as I would like. We're in a situation where our traffic is still 64% lower. So all of the industry are suffering in terms of the carriers and also the airports. And that's why it's very difficult to get people to participate in innovation and long-term activities. But realistically, we will see a situation where this will actually come out in the next number of months. So that's very, very important. But it is a tricky situation for us all. And you can see that the carriers are suffering. But equally, the other part of your innovation project and where you spend a lot of time is the airports. And what's really important to look at is that complete collapse in revenue of airports over the last number of months. You've had, you know, significantly, like airports like London Heathrow have had a 75% collapse in air traffic. And you can see the two biggest airports they're operating, like Istanbul, have two airports, but it really has been unprecedented situation that in 35 years in this business that I've never seen something like this before. And it has sustained for such a long time. Hugh, who is on with you there today, will be very familiar with the fact that, you know, the market segments have collapsed. I mean, cargo is the only thing that's surviving. Some of the traditional carriers are operating a limited amount of operations, primarily domestic, and low-cost operators have collapsed. So it's a difficult situation. The other thing I just wish to say is that there is some hope in that we have to realize that in Europe, we're suffering the worst of anybody. All of the rest are recovering. The domestic operations in the United States yesterday were down 31% on 2019. And you compare that with Europe at 65. And you can see that actually, look at the domestic operations in China. They're increased by 10% over 2019. Still international. So I think we're facing another 4 or 5 difficult months until we get this vaccine situation much more. Now, to talk about innovation, what's really important is to put this behind us and park it and accept that, yes, we're in this situation and try and convince the people that we need to look at how we will tackle the next 10 years. So first of all, we have to be aware is that COVID has changed the market. Competition has been changed. To an extent, competition has been distorted. So the appetite for carriers and airports for innovation, we have to be clear that we have to have it very targeted. The decarbonisation of aviation will be very centre stage with the Green Deal. So everybody will be looking and all of the projects for SESAR 3 and all of the innovation projects and things that airlines will want, such as EasyJet, who you have there today, will be decarbonisation, electrification, and, you know, also hydrogen activities. And also, of course, for you, Laurent, there, and for all of our supporters in the Innovation Hub, the digitisation is very, very important. So there's 3 elements I just want to talk about in the evolution of innovation. And to me, innovation is important because we should never lose innovation. Sometimes we get trapped in what I would call mundane research. And what I call by mundane research is where we're producing vast amounts of stuff for the long run. Here we need to produce stuff for the short run with a real problem in mind. And this, where I think, is that we have the category of the SESAR 3 research. The new SESAR 3 will be going directly from research to deployment. And that's what I want to achieve in SESAR 3. And this is very important. The second element is to preserve innovation. This is where we look at specific problems for specific clients to solve a specific problem. And this is where I think the innovation hubs will be really, really important. And of course, in Brétigny, the simulation facilities, and that it's the only place in Europe at the moment. And we are looking, Laurent, at renewing the team as part of the network management upgrade as well, and using cloud facilities to look at our new simulator. So it's in this context, you know, that the innovation hub at Brétigny has started over the last year. And I congratulate you, Laurent, on getting to this milestone of at least having a review, because one of the criticisms I've always had is that it's important you have clients. Who are the people you're dealing with and why are you doing it? So for me, the innovation hub basically has four things. We have the support from stakeholders. We need to streamline the whole issue from innovation to deployment and to make sure it's agile and to complement SESAR. So Laurent, I wish you and your teams the very best today. It's a difficult situation we're operating in. I'm really pleased that you've taken this initiative, and I'd like to thank all the speakers who are actually working with you today and wish you the very, very best of luck. So that's it from Brussels. Thank you very much, Laurent.
Thank you, Iman. Thanks for your introduction. Very clear. Today we have two sessions. The morning session, and this morning session will target the operational stakeholders. This morning session will be divided in two parts. The first part where we will present the result of the 3 projects performed during the first cycle that ran from last summer until March 2021. We will present what were the needs of the 3 projects, what were the benefits expected, and also what was the result that we achieved. And then from 11 to 12, we'll move to the second part of the morning session, where we'll launch the 8 projects that has been selected as part of the second cycle. So that will be for the morning session. And then we'll have an afternoon session where we will target the technical stakeholders, because here we would like for the 3 projects to go in more technical details of the achievements that we have for these 3 projects. So that's for the overall agenda. Now let's move to this innovation initiative. And just to remind everybody about this objective. So first, as Iman said, it is open to all stakeholders, airport, ANSPs, and airspace users, and we really want to address your needs and develop digital solutions and services, with the goal to accelerate the market uptake, as Iman was saying, to streamline from innovation to deployment and to target short-term operational improvement. And as Iman was saying, to complement the SESAR program by bringing agility into the SESAR program. So for this, we would like to develop an innovation hub at EUROCONTROL Brétigny, where on one side, we'll partner network with the operational stakeholders, ANSPs, airport, airspace users, and on the other side, we'll partner with research center, university, that will help us to develop the digital solution and bring innovation. So now let's see the innovation process that we have defined. Actually, it's very simple and pragmatic, where we combine our expertise with the agility that is needed for such an innovation initiative. So first is the connect part, where we'll collect and and select the subject, the operational needs that we would like to develop. And that's a way to create this European network approach. Then we'll build, so we'll develop the prototype addressing end user needs. And there is a promote event like today. Today is the first one, where we share the result of this cycle and we move to the next cycle. So it's 6-month cycle, very pragmatic, very simple. So actually, we already launched this initiative 6 months ago through a pilot phase, because we wanted to be pragmatic, to start small, learn by experience, and grow gradually. So last summer, we were able to connect and collect needs from 7 airlines, 1 airport, and of course, the EUROCONTROL network manager. Altogether, the operational stakeholders proposed 12 different projects and 3 has been selected. So now it's time, to present to you these 3 projects. And for this, I leave the floor to Peter. So Peter, the floor is yours.
Good morning, everyone. Thank you very much, Laurent, for the introduction. And of course, thank you very much also to Eamon Brennan, our Director General, for the keynote speech that we have heard. And I'm really honored to be able to present and to moderate this first session, where we will present the outcome of the first 3 projects from the pilot phase that Laurent just introduced before me. Now, before we enter into the subject and start to talk about the project, let me just tell you one thing, that once you see the projects, there'll be high-level overviews of these projects. Only 10 minutes, we will have the presenters that come from the operational world, so operational stakeholders from the airlines and 1 airport. They will be joined by the project experts from EUROCONTROL. And what you will see in terms of the projects, you may ask yourself, like, is this revolutionary or some disruptive innovation? Maybe it will be not. But what it will be is potential incremental innovation. And one thing to remember is that as within this process, these projects did not exist 6 months ago. So basically in September, the ideation process has taken place. The ideas were born in October. We've kicked off the projects in end of October, early November. And now after 5.5 and 6 months, we are seeing the fruit and basically the first prototypes that have been built and will be presented to you. So without the further delay, I would like to maybe just quickly mention that unfortunately, in this morning, we will not have time for the questions and answers for these 3 specific projects, but you will have that opportunity in the afternoon. As Laurent explained, in the afternoon, we have more detailed session where the 3 projects will be presented in more details and you will be able to ask your questions. If you would like to put some comments there for the project leaders or presenters, you can still use the Q&A panel. Please, the chat panel, use it only in case of some emergencies in terms of the technical problems that you would like to write something there. Now, let us go to the first project that will be presented today to you. And the subject of that, the title is Prediction of Waiting Time at Arrival. And I would like to welcome the first 2 speakers. The first one being Cyril Kanu, Head of Operation Control Center from Transavia, and he will be followed by the project leader from EUROCONTROL, Karim Zegal. So Cyril, over to you.
Thank you, Peter. Good morning, everyone. So holding time at arrival is when you believe that you arrived, but you still have to wait a bit more. So Transavia France is the low-cost part of Air France Group and is flying over more than 100 destinations over Europe. In 2018 and 2019, almost 60% of our destinations were impacted with holding time at arrival. 2% of our flights were impacted with average 10 delays due to this holding time at arrival. We observe on this historical data that there was no evolution between 2018 and 19, but this situation induced another consumption of around 230 kilos per flight, which represent for our operation almost 180 tons per year, which also represent almost 600 tons of CO2 per year emitted. The good point on this situation is that there was no major, no safety event at all on this holding time. So this situation induced to go through a project with the main operators in this area, meaning Air France, EasyJet, Ryanair, Swiss, and Vueling, to as this reflection on how can we prevent this situation. So the idea is to get to have a better prediction of this holding time at arrival, considering additional data like weather, traffic demands, or historical data based on the operator's data. The objective is to focus on the pre-flight phase and to define this holding time into 3 categories: the small delays, less than 5 minutes, moderate, between 5 and 10 minutes, or higher than 10 minutes. Karim will present you the outcomes of these studies.
Thank you, Cyril. Morning to all. So very quickly, and I encourage you to join this afternoon. So what are the outcomes? What was achieved? So if you go on the right, on the top right, you'll see we have established a baseline model. So that takes the time and the date and statistically determine a waiting time. Also, what we have done is we have developed iteratively an AI machine learning model that takes the time and date plus other information like the current waiting time, the traffic demand, and weather, and provides as inputs a waiting time probability. So that's basically what the model is doing. So if you go now just below, you see a graph. So on the x-axis, you have the three classes, the three waiting times, so 0, 5, 5, 10, and more than 10 minutes. And on the y-axis, you have the waiting time error. So typically, if you focus on the high waiting time, so 5 or more than 10 minutes, you will see that in fact the model beats the baseline. So you see the average or the median value is 0, and I mean dispersion is less than the baseline. So baseline is violet and green, the model. So the model beats the baseline. However, there is still a dispersion, and on this high delay, that's the third quartile. So still we have a prediction error, which is less than the baseline, but still it's here. And we believe, and we'll discuss later in the afternoon, there are uncertainty, like the takeoff time, there could be unexpected event that would maybe prevent from reaching a perfect prediction. So that's what the model does. And as Cyril mentioned, we have made a case study with airline data and show potential benefit, and we'll give you more detail this afternoon. Okay, that was achieved. Still some open question. We need more comprehensive validation with the airlines. We need to improve the model. We have ideas. Also, we need to discuss the possible interest for airports which are moderately congested. And also, we need to look at possibly longer look ahead and the link with the in-flight modes. So very in short, and I'm finished. To take away, so we have promising results. However, we need to go for a full operation benefit with the airlines. And by the way, there was a potential quick win for the top European airport with the baseline. So the statistical reference already, it could be something that could be made available to be discussed. That's all for me. Hope to see you later in the afternoon. Thank you. Thank you all. And Peter.
Thank you very much, Karim and Cyril, for this brief overview of the first project. Again, as the two speakers have said, if you would like to get more details about this project, there will be a bigger slot, including the Q&A session in the afternoon from 14:00 CET. So let us now go to the second project that will be presented in this session. And that second project is called, as we call it, FATE, Forecast of ATFM, Air Traffic Flow Management Delay Evolution. And I would like to welcome the speaker from the operational world, from the Vueling Airlines, who is Mr. Oliver Iffert, the Chief Operation Officer, who will present the challenge and the background for this study. Oliver, over to you.
Yes, hello, good morning, everybody, and thanks, Peter, for the introduction. So in Welling, due to being in Barcelona and Barcelona being at a very specific location in Europe, we are really highly affected by ATC delays, and that's why I have very much welcomed the initiative of EUROCONTROL when Carlos asked me whether we can participate to help in innovation and improving the current situation. So from a Welling perspective, we are a great supporter of this initiative. And one of the things we have worked on together with EUROCONTROL is the forecast of ATFM delays, which has a huge impact on our operation. And I'm sure everybody who's from the operations world here on this call will understand that I mean, it's an impact on stand allocation in airports, delays for passengers, standby crew activation, of course, on-time performance in general, operational displacement, loss of resources, no accurate information for the passengers, which is a big issue, and leads to a degradation of NPS and revenue. We see that we have issues with connecting flights, etc., etc. So for us in the operations world, it is really a major advantage if we can project how the delay is moving throughout the day and throughout the life cycle of the flight. We took out as one example during the works on this project, a flight from July 2019, where we had 43 different slot allocations to this particular flight. And you can imagine that this is extremely difficult for the operations manager in the IOCC, for the crew, for the airport crew, to manage a situation like this. On that particular day, I think we activated around 193 standby crews. Some of them activated and actually never made it to a flight, because the flight was so much delayed that they had to step down again, and we had to activate another set of crew. And this is a huge issue, not only from a cost perspective, of course, for the airline, but the inconvenience for all the resources. And it has a huge knock-on effect on all other infrastructure affected by that. So with this tool, what do we want to do? We want to make sure that we can predict the evolution of the CLTLT, correctly allocate our resources, inform our passengers accordingly, so they can plan their trip. They can we can plan connecting flights. We can avoid that there is congestions in the terminal. We can optimum allocate our resources on the ground, engineering, ground handling, and of course our crews. And we can also plan the aircraft routes accordingly. We can swap the routes. We can adjust our maintenance slots, etc., etc. Because as you all know, it's a very complex puzzle that needs to come together on these particular days. So the more information we have on how the day is going, even to the point that we say we might cancel a sector or so, is very helpful for Welling. I'm very glad that we are able to participate in that and generate a tool that can help the entire infrastructure to improve the management of this situation. So Peter will give you a little bit more input on this from a technical perspective. Thank you very much again for letting us participate. Peter, please.
Thank you very much, Oliver. And also thank you for the introduction. You introduced me because I happen to be not only moderator of this first session, but I was also the project leader for this specific project. So yes, it will be me presenting now the outcome of this. I would like to also say that, of course, apart from Vueling, who now kindly presented to all the participants the original challenge and the idea that was behind this project, we had also a few other airlines that participated actively to this project. There was Air France, Transavia, Swiss International Airlines, Ryanair, and Wizz Air. Now, what did we do all together within the project team in EUROCONTROL and all participating airlines? As we kicked off the project only end of October, we had to, of course, start with the proper scoping of the project. What exactly, listening to what we've heard now from Oliver and listening to what are the desires of the project and the real need, what we should be trying to solve in this quick innovation project. So we've tried to scope it, and the original idea was, can we get the trend for the delay? Once our aircraft is regulated and is delayed, is it gonna the delay increase? Is it gonna stay stable, or is it gonna reduce? Now, once we started to already look into that, then what data do we have? How can we build the artificial intelligence models that can try to predict this? It was clearly obvious that we can not only provide the trend, but we can also provide the predicted delay itself. So we've agreed on that. We've also agreed that we will try to integrate the AI model in a prototype where the users can get their hands on and try to use that as an example for their operations. So there was a prototyping element that the team has worked on. And of course, we also agreed that if possible, we will try try to do a live demo where the users can actually connect to the tool, and so that's why I will give you a quick overview now. In terms of the summary of the quick summary of the project results, the modeling team has built actually at the end more different AI models. We've built in total, I think, 5 models that have been trained and benchmarked. Different metrics has been shown to the users. On the right side, you can see, for example, we've been looking at the performance of the model for each airline, cumulatively in terms of mean absolute error. Can we reduce the error of the prediction of the delay by the machine learning model versus the current what we call the CASA predictions. So you see that, for example, for Air France, if I check on the bottom sorry, on the top right graph, you see that 10 minutes was the average error, and the model is basically predicted the error of the model is only like 4.5 or 5 minutes. This is per airline. We've done this per departure airport, arrival airports, the city pairs, many different metrics. You will hear more about that in the afternoon when we enter into the details of the model output. At the end, once we've benchmark the models together with the users, we have decided to choose the 2 models that are complementary. Why complementary? They provide the trend that was originally requested by the users, but they also provide the predicted delay and a notion of uncertainty that is very important. As we know in this business, you know, it's a lot uncertain. Particular model we've choice was the hierarchical recurrent neural network that was applied. We have then built the 2 versions of prototypes. Why 2 versions? Actually, I can come back to the keynote speech by Iman earlier today, who said that, of course, unfortunately, we are in this COVID situation when there is not a lot of traffic out there. And when there is not a lot of traffic out there, there are not a lot of delays. So when we wanted to run a demo with testing the model, we actually needed some sort of delay. So we had to build what we call a replay type of prototype, which we can replay the situation from pre-COVID times when it was still busy and a lot of delays. So in 2019, the airspace users have chosen the 3 days of their interest, fairly average day in spring, then very busy day in summer with a lot of weather events, and also an event with ATC strikes, which of course nobody likes, but they are part of the business. So we wanted to see how the model performs in these different events. We've seen delay prediction error reduced up to 63%, which is incredible improvement. And this is primarily 4 hours before the takeoff. As we are moving closer to the takeoff, 3 hours, it goes to maybe 40% improvement. Then you get maybe 30 or 20% improvement 1 hour to take off. And when we are getting in the last 1 hour, of course, the prediction model is converging more with the standard CASA delay because it's becoming more stable. We have seen a slight performance drop in particularly the unstable days. What we call unstable days is the days with a lot of weather events, the thunderstorms, that of course the predicting them, the location and the duration of the regulations is of course not that easy. So there we have some more work to do in order to improve the performance. We have received positive feedback on the new indicators and the HMI, the way it was presented, these new indicators to the users. So, and of course, the second prototype that was built apart from this replay is the real shadow mode prototype, which we can now hook on the operational data and try to use it in the shadow mode operations. That brings me to the next steps and the final summary, that the users have clearly requested the shadow mode trial to be executed, if possible, even if the traffic picks up in summer, to try to gradually use in the shadow mode operations, try to gain the trust by the operators and flight dispatchers when they use the model. We have started our discussion with the network manager, who should be the one basically deploying this solution. And then, of course, we have identified a couple of model improvements that we will again hear about a little bit more as a teaser in the afternoon, where we can get the model performance better. So that's about it. That sums up the outcome of this project. And we can move on to the third and the last project that basically we presented as within this pilot phase of the projects that were run in the last 6 months. And now we have actually 4 speakers that I need to introduce, because this is about collaborative management. It's a Curfew collaborative management as a project title. And I will introduce you. The first speaker will be Eric Nantier, who is head of ops optimization and development in Lufthansa Group from Swiss International Airlines. He will be followed by Thomas Dubu, who is operations director from Aéroport d'Orly. And then Thomas will be followed by Hugh McAnalock, who is director of operations from Gatwick and director of ATM strategy and delivery from EasyJet. And of course, at the end, you will hear the final summary of the results by the EUROCONTROL project leader, who will be Giuseppe Murgese. So now I hand over to Eric to start the presentation.
Thank you, Peter. Good morning, bonjour, guten Morgen, ich bin in Switzerland. Great to see miteinander from Swiss, Lufthansa Group in Switzerland. The target of Curfew is to reduce noise around an airport. But for us as an airline, any aircraft aiming to land or take off during the curfew will be diverted or cancelled, what has directly an important financial impact. For us as a hub carrier, the prediction of curfew infringement is a key factor to act proactively and anticipate possible action. We airspace users have a limited visibility for our own flights, but we don't have any visibility for all our flights incoming in our hub, bringing additional workload or late connection, what could possibly impact our late departure flights. Knowing that EUROCONTROL, stability as a network manager, have a huge amount of data that could be used to predict the potential curfew infringement. Our request was to build a high learning machine, something like this, to provide a trained learning from the past and to predict the delay of the last flight as potentially infringing a curfew. Airspace users, like airport, we need this information to assess the potential impact on our operation and act proactively to reduce our workload and offer the best possible services to our passengers. For the next point, I will introduce Thomas Dubus from Aéroport de Paris, Orly. He will give you the airport view on this request. Thomas?
Yes, hello, Eric. Yes, hello, Eric. Hello, everybody. Actually, the position of the airport is very close to the one of the airline as far as the curfew management is concerned. The curfew management is a top priority for an airport as wholly as curfew can have impact on efficiency of operation, impacts on passenger satisfaction, and of course, impacts on our business model of each one of us. As far as the whole player are impact, it's an opportunity to work together, ATC, airline, airports, to try and detect as early as possible the potential curfew infringements. So this tool from EUROCONTROL makes it possible to work together and to share information in that purpose. From an operational point of view, curfew management gives us time and anticipation to analyze the potential alternate ports of diversion that the aircraft and the airline may use. Moreover, this time is crucial concerning the potential turnaround to come of the aircraft that may break the curfew. This time makes it possible for us to try and accelerate the rotation by giving the best condition possible. On Orly, our APOC is able to alert partners on the flight of an aircraft that may arrive after the curfew and to monitor those flights very carefully to reduce as possible the time on the ground of these aircraft. Concerning the last arrival of this aircraft on the airport, hoping it's before the end of the curfew, we can anticipate the arrival of the aircraft and prepare all the means on the ground to welcome this aircraft. So those actions definitely help to mitigate the operational impact, but also the negative economic impact of this curfew and the break of this curfew. This serves the economy of the airline, but also the economy of the handlers and of the airport, and it makes us possible to adjust all our resources and to improve in the best way our economic model. So that's it for the airport.
Thank you, Thomas. So from an airline's perspective, the causes of infringement of curfews is often out there space users control, whether aerodrome or airspace capacity, and there's something that our ops centre staff have to deal with as the situation develops and as problems or challenges start to show themselves. More often than not, those repeat challenges in any operational day and in a sequence of days can focus problems for any airport and for any operator at that airport and have a longer term impact on how the operator's model works at any airport that has those restrictions. It's clear that where we are today, campaigns at local and at political levels will only mean one thing: more curfews and more restrictions. And that means we have to use data in a more intelligent way, and we have to be able to enable our staff to better predict and forecast the outcome of the day. Being able to predict and forecast what we're doing will enable our ops staff to make a better decision and make the decisions earlier, thereby reducing the impact of any disruption that may come about. Now, while the operational impacts are obvious, I think it's all, and there wouldn't be a surprise to anyone, I think it is good to always highlight them, and it kind of gives a good basis as to what airlines and what ops centre staff are constantly working with. So infringement of curfews is inevitably going to end with aircraft being based out of position, so they do not end up where they're supposed to be as per your schedule and your plan at the end of the night. And in line with that, we end up with crews out of position as well, thereby disrupting our crew schedules, not just for that day, but it will look, that disruption to crew schedule will run on into the rest of the roster for those crews. Passengers, the obvious disruption piece, our customers end up where they're not supposed to be, and they end up feeling that they've had a bad experience by the airline. They can often lose faith in the airline, and they won't understand or won't see what a curfew has caused or why it has caused it. The perception will always be on the airline and the supplier of the travel. What this all contributes to operationally is a vicious circle. So if your aircraft are out of crew and out of position and your crew are out of position, that often starts the next day where you're behind the curve, particularly in peak schedule periods where your aircraft are allocated to lines of flying and you've got a schedule to run, but you're starting the day with your aircraft and crew out of position. That can then likely impact the airport that it started at, and the curfewed airport once again gets hit. So this cycle of disruption can continue and is often only broken by cancellation of flights. The economic impacts equally as important, maybe not as obvious as the operational ones, but the costs that are incurred as a result of this disruption where we infringe curfews will include positioning flights to try and get aircraft back, to try and move spare aircraft into the network, to try and manage the disruption that's being caused there. Any ad hoc passenger handling and accommodation costs, we know now that today that there's a big focus on how we look after our customers and how every airline manages its customers during disruption and what service we provide to them when they are not either departing on the time that they should be or arriving where they should be. Exposure to the compensation claims under the 261 compensation regulations. So for just the matter of minutes of delay, we can end up paying out compensation to entire flights. That is very high cost to airlines. And when we go back to the summer of 2018 or 2019, with the levels of disruption we see, that can be a huge cost now to all operators and all airlines as we move forward. We also have the hidden cost of trying to avoid curfew disruption. So we move aircraft around, we will adjust flight plans, we will fly at different speeds, all in an attempt to try and avoid a curfew bust. Now, if we knew earlier in the day, we may not have to take such drastic actions to try and move. So the sooner we know about this, the better. The loss of performance on any given constrained airport or impacting a particular sequence of slots also has implications for future schedules and how an airline can maintain its slot portfolio through that. requirements of any tool going forward. So the work that has been done here for us, the main aim is to be able to predict and forecast earlier, to be able to see what's coming, and to be able to take the relevant steps earlier to reduce the impact and the cost of any impact that comes. It's also important for us that in a busy network and a busy operation, that any tool or any data we now surface or we now bring to our ops centres, it has to be integrated in the systems we use and the processes we use. It's with the amount of data and information available to operators today, it can become overwhelming if you're using multiple different tools and multiple different processes to manage an operation. So integration is also key to this program. So I'd like to hand over now to Giuseppe, who will take us through the work that has been achieved on this program.
Thank you very much, Hugh. Good morning, everybody. Thank you very much, Hugh, and actually thank you very much to the three speakers, because they said it all, basically, in terms of issues and in terms of needs from the end users on how to address this problem in a different way and help, of course, them to solve it in operations in the future. It was thanks to their input and to the other participants of the project, which I would like to thank, which is Ryanair, Transavia, Vueling, and Zurich Airport, which actually joined the project at a later stage, that we could achieve very interesting results that you will see in detail this afternoon by participating to this afternoon session. What you can see here on the slide is an high-level presentation of those. Basically, on the right side, on the plots there, you can see just examples for the airports which have been involved into the project, Orly and Zurich, and for the airlines in there, and the three phases of our experimentation of our experiment, which is the 2018, some 2018 data, 2019, and even 2020 for the COVID period. Not easy to do. We actually ran it in the same way that for FADE for the previous project has been done, because given the current situation was very difficult to actually run in live mode. But we did it in a mixed mode between the replay of previous past traffic and the current one, which was last year. You can see on the left side the average results of this experiment, between 15 and 35% of improvement with respect to the current operations, referring to the current NM system, like the ATFM data, which provides basically the actual data for the flights all over the ICAC area. What is important to say there is the fact that we picked up critical data from 2018 and 2019 traffic based on the input by our partners in the project. Critical because it was important somehow to stress the model, the AI-based model, on traffic situations which were very difficult to run on the day of operations. Weather conditions, technical issues, the ATFM huge delays or strikes whatsoever. As far as the 2020 traffic is concerned, then you can see a slightly less improvement on the average performance of the model, between 5 and 12%. And of course, it can be absolutely understandable because the traffic was completely different in the way it was run in 2018 and 2019. The very last step in the project was the initial integration of this model into the airport operational platform Mirror in the flight watch panel. And again, this afternoon, please participate to the session because you will see a live demo of this. What is next in this sense? Well, potentially a further development of the Mirror HMI, of course, a massive end users testing and training, I would say a sort of operational assessment to be run by the end users in data replay or shadow mode. We'll see. It's not decided yet. And of course, based on the outcome of these two previous steps, we target a potential deployment by summer 2021 in the Mirror operational version. For a future, I would say mid-term future, we already started discussing internally with our NM colleagues. We also look at, in this sense, for a potential integration of the AI model of the tool into the future version of the CHMI, the NMP flight, which is being put in operations by NM in the next months. So please, for the very useful and interesting detailed results, participate to this afternoon session. Thank you, and thank you, Peter.
Thank you very much, Giuseppe. And of course, thank you very much to all the speakers that have presented their work in the 3 projects in this short session that we had this morning that was focusing on the outcome of the cycle 1 of the pilot phase. Before I hand over back to Laurent, I would like to just wrap it up with one takeaway message to all, and that is to really reflect on this EUROCONTROL Innovation Hub initiative that we have launched only 6 months ago, where 6 months ago, as you've heard from the operational stakeholders, they came in October, September, October, presented a specific challenge. Then EUROCONTROL has put together the team of experts and has leveraged on the huge amount of the aviation data that we have with the in-house expertise, and we have developed basically all 3 models we have seen are using the artificial intelligence machine learning models, and we've put this data in good use, build the models, developed prototypes, and got the users to get their hands on. And we will be now moving on to the next stage, discussing on how we can bring this into the operations. But what is really amazing about this whole process, and I'm really thankful to everyone who was involved, including all the airlines and the airport that were participating to this project as our partners in this, that we went from this step from originating the idea to producing the final outcome in the short amount of time in 6 months. Now I will hand over back to Laurent, and I thank you for your attention. And as of course, as Giuseppe mentioned, please join in the afternoon to get more details on this project. Laurent will now speak to the operational stakeholders and talk about lessons learned and the next steps. So I hand over back to you, Laurent.
Thank you, Peter. So thanks a lot for the presentation of the result of the 3 projects, the needs, the benefit expected, and the achievement done during the last 6 months. So now let's continue this morning session and exchange about this initiative. Actually, as I told you, we decided to be very pragmatic, to start small, learn by experience through this pilot case, this first cycle. And now it's time to share the lesson learned. So I would like to take advantage of your participation, so to share with us your feedback. So I would like to start with Thomas from Orly Airport and talk about this objective of our initiative. So this innovation initiative objective, as I say, is open first to all stakeholders, and it's really here to address end user needs. So what is your view, your feedback about our innovation objective?
Well, Laurent, actually, currently airports, airline, I think all players of the industry, we all face a very difficult situation. And this has been, of course, already highlighted. We consider that during this low traffic period, we definitely have an opportunity to develop game-changing solutions and innovation that will make us more efficient when the activity will be restarting. And of course, the sooner, the better. We want to be stronger at the end of this crisis than what we were at the beginning. And definitely we are pleased to have EUROCONTROL supporting us in that process and supporting us on keeping innovation and addressing operational needs. Definitely with this project, we see the strength of EUROCONTROL able to bring positive results on the project within 6 months. And I heard that the product should go live in summer. That's great. And able also to have all the players of the industries working together. And I'm glad to see that already, I think a dozen of airports already joined the process. And that's very good news that we all work together to make this industry stronger during the crisis.
Thank you, Thomas. So let's move to you from EasyJet. So we define our innovation process in order to be simple, pragmatic, agile. But this is from a EUROCONTROL point of view. Now, from an EasyJet point of view, a low-cost carrier, are we simple enough, agile enough, pragmatic enough? What are your feedback? What is your feedback, you?
So I think for a start, we'd say the project, the work has got off to a very good start. We're very appreciative of the pilot project approach. I think it's a good approach. We're always keen to see results when this work starts. And I think if we look back at what Eamon said at the start of the call, that we can tend to focus on the longer term too much. And from a low-cost carrier's perspective, we can become quite frustrated, wait and see results. We end up looking too far into the future and we don't see any incremental improvements as we go. So I think the way this has started, very positive, and I would urge that it continues in this direction, and we look at what gains there are to be had in the near term and build on that for the future. I think across the teams, I think with the EUROCONTROL staff and certainly our own staff at EasyJet, the engagement has been good. It's good to see the discussions that are raised through this process. It opens up. I think sometimes we can sometimes miss the benefits of operational experience actually leading or informing the needs for data-led developments. So I think this kind of partnership works well. And again, I would hope to see that to continue on, because we always have to be mindful that the work we do here has to feed and serve the customer and the user at the end of the day. It mustn't be technology led for technology's sake. So it's kind of it needs to have results, and it needs to deliver. So I think that's good. It got off to a great start on that, and I'll fully support continuing on that. 6-month cycle, we would take that as a good cycle, but we'd always say, can we have it quicker? We'll always take shorter than 6 months if we can. But obviously we want it to work, and we want it to be done correctly and get good results out of it. And I also think as well that there's a positive in this, that we haven't had to wade through huge, great documentation and project plans and huge, great pieces of work to try and get somewhere. So I think, again, focusing back on that agility, that ability to look at a problem, look at the data that's available, and then move forward. I think that's really important. Let's not spend huge chunks of time producing great big presentations, documents, and everything else that at the end of the day we miss the cause of the project in the first place.
Thank you, Hugh. Thanks a lot for this. And indeed, back to this 6-month cycle. Just to be sure that is well understood, this 6-month cycle first is here to capture and launch new project every 6 months. And it's also here to be able to stop any project if we know we cannot find a solution. So it's a way, and it will happen for sure. So it's a way to be sure that we'll not continue working on project forever. No, after 6 months, if we don't find anything, let's stop it. And now on the result, well, we have to be clear that we might need more than 6 months, as it was the case, for one project here. So we might need more than 6 months to reach the maturity needed, what we call this minimum valuable product. So we might need, 2 cycles, 12 months, 3 cycles, 18 months. So we will see. So that's why we don't want to also raise expectation that we will not be able to meet. Sometimes, as you see, in 6 months, we'll be able, to deliver results. Sometimes we might need more than 6 months. But again, thanks you for your feedback. Now I would like to move to Cyril, and so Cyril from Transavia. Through this pilot phase, we change at EUROCONTROL the way of working by having more interactions with your staff, operational staff, and on our side it was well appreciated. So what is the feedback on your side?
Well, thank you, Laurent. Indeed, working closer with EUROCONTROL team brings us a lot of benefits. Felt integrated in the project, so this is the feeling of all the operators, and we can address directly some operational subject and matters that we are facing day to day, and to your expert and work together on this subject. The one I presented is unfortunately not, as you said, terminated yet, but we are looking forward to still continue to work on this solution, on this model, to have this solution available on an industrial way. The EUROCONTROL staff demonstrating its ability to work in an agile way, which is for operators really appreciated, as the project is generally in a short-term duration for operators. We expect to have answers within few months, so it's promising. And despite COVID situation, the organization, the coordination of the working session was not a big issue, as it has been always organized remotely, and taking consideration of the constraint of the experts on your side and on operator sides. So thanks for this organization.
Thank you, Cyril. So let's move to Oliver, the operation director from Vueling. So we just mentioned working together, the development team and the operational staff is really the key for the success of this innovation initiative. But it means that on our side, we need commitment from your side to provide, let's say, about 10 days of operational staff within a 6-month cycle. We work in a way like it was every 2 to 3 weeks, half a day, 1 day working meeting with your operational staff. So it means 6 months within 6 month cycle, 10 to 12 days of your operational staff. Was it difficult on your side? What is your feedback, please?
Yeah, thanks, Laurent. To be honest, as I said in the beginning, I was very delighted when you approached us in October with the idea of creating these initiatives, and we in Vueling we are very supportive of this, because we see the absolute need not only to develop these tools but also to further strengthen our collaboration on practical topics. And I want to go back a little bit to what you said. We have seen in the past large scale of project initiatives, strategic developments, etc., and many of them have moved in very small steps, but we don't really see the progress day to day. And I think changing this to a more agile approach, getting a group together, defining a problem, and then start working on it and see the outcome is absolutely what we support. And that's why our commitment to provide the staff and to provide the expertise and to provide the resources will continue, as I strongly believe that we get a positive outcome, not only for us in Vueling, but for the entire industry.
Thank you, Oliver. Let's move to the last panelist, Eric from Swiss. So our goal is to address your needs, but with a pan-European view, pan-European perspective as EUROCONTROL. So when we agreed to work on this Curfew collaborative management, we know that at the beginning it was for Orly. Orly Airport was actively involved, but also with the view that it will also address the other European airport that has a curfew. So from an airline point of view, how is it easy for you to share your airline's operational needs with your airline competitors like Vueling, Transavia, or other airlines that were already part of this initiative?
Okay, thank you, Laurent, for the question. First of all, and for the innovation hub that we launched in the last 6 months, something very important is to be very quick and certainly yet in a recovery mode from the crisis COVID, and to add the low-hanging fruit as soon as possible. Clearly, our challenge in the future will be environmental, like Eamon Brennan said, and after the crisis recovery capacity. And both subjects is not possible. Well, not possible to solve it inside Swiss or inside a Lufthansa group or an Air France group or something like this. We need the participation of all actors. We have to share our need with other airlines, but other partners like airport and ATC provider, so that we are able to achieve something. Only one company alone is no more able to make this kind of environmental saving or increase of capacity. Of course, we have confidential data, and we are not able to give this confidential data. Swiss is actually working on an Horizon 2020 project where we try to demonstrate how we could make learning machine without to give this kind of data, but to share our needs with other airline or airports. For example, in this Curfew project was very easy because we have the same problem. And if we want to save or to resolve this kind of problem, we need to make it together. Airline, airport, ANSP, EUROCONTROL, of course. Sometimes our ground facilities in an airport or something like this. And all of us, we have to work in the same direction. And like I say very often, for the ATM world is very important. Please don't forget, we don't just fly aircraft. We move passenger. Our target is to bring the best services on the passenger. And certainly the Curfew project was a very good example how we're able to work together. And I think it was not a problem, inclusive from the manager point of view, but for the employee, for the youngs who was working on the project, was very easy and very fruitful to make the job. Of course, and like it was said, we are waiting very clearly that we have the interfaces to receive the result and to put it in our own system in a B2B principle or something like this. And of course, we are able and willing to continue to work this way with the InnoLab. But for me, if we could do it on other projects like the SESAR PG, etc., and be able to push and to be quicker to deliver some result, like for the target time of arrival, it will be great. I will support that clearly.
Thank you, Eric. So now it's time to close this panel session. So thanks a lot, Thomas, you, Cyril, Oliver, and Eric for your feedback on the lesson learned. So of course, on our side, we'll do our best to improve ourselves. And as Eamon mentioned, actually, it is important that through this innovation initiative, we have customer, and as Hughes was saying as well. So this is the spirit of this innovation initiative, as you could have seen through this pilot phase. But now let's move to the second part of this morning session and to present you this the second cycle that is about to be launched. And so actually, let's say it's a growing success now that we were able to connect and to contact, to present this initiative also to ANSPs and to other airports, as Thomas was saying, so to ACI and another dozen of airports. And for the ANSPs is mainly so far the ANSPs that are in the SESAR joint undertaking admin board. So altogether, it's 30 end users involved in this initiative for the second cycle. And now I will leave the floor to Marta, that will present you in more details the 8 projects that has been selected for this second cycle. So Marta, the floor is yours.
Thank you, Laurent. Good morning, everybody. So I'm really glad, to be here with you today to, as Laurent said, introduce you the cycle 2 of this innovation hub. After having seen all these achievements of the cycle 1 projects, thanks Peter and all the speakers, presenting all the results that has been taking place during the 6 latest months. We are going to start describing for you and presenting for you the new ideas that will be the challenge for the cycle 2 of the Innovation Hub. So before starting with the different stakeholders that will be presenting these proposals, let me explain you the process by which these ideas were selected. So in the Connect phase, as per the Innovation Hub, there is the process of ideation. This process started end of January with the call for operational challenge and needs to all the end users that Laurent presented. And this period of challenge submission was run for several months. And at the end of this period, there were 3 pitch sessions that were organized in which the stakeholders could present their proposals, and these proposals and idea could be discussed by all the participants. At the end of March, there was this period of submission ended, and a prioritization period done by the end users started, in which they provide a ranking of the ideas, and afterwards there was the feasibility assessment done by EUROCONTROL that at the end provide, based on these 2 outputs, so the ranking, prioritization, and the feasibility assessment, the selection of the ideas that we are going to present today. So today is the official, let's say, presentation of these new challenges in this promote event. And just for you to know the different stakeholders that were participating to this ideation process. From all this period of ideation, we had 16 challenges that were submitted by the different stakeholders from airports, airspace users, and from air navigation service providers. From these 16, following the criteria that I explained and the process that I explained just before, there were 8 of them that were selected to go to the next scoping step in the build phase. So let's take a look on these new ideas and challenges for the Innovation Hub. So as you can see here, we have the 8 of them. There are 3 of them that were proposed by the airport stakeholders. So we'll have Geneva Airport, Gatwick, and Milan Airport presenting. Then the airspace user, they have 2 proposals for this cycle 2, Air France and AOPA. And the last part of the presentations will be related to ideas from the air navigation service providers. So we'll have DSNA, NATS, and NIRIN presenting. So with this, I think that now it's the time to give the floor to our stakeholders and our speakers. So I will be more than glad to give the floor for the first presentation, for the first idea, to Giovanni Russo, who is the Operations Director in Geneva Airport, and he will going to explain to us the idea about optimization of airport resources. So Giovanni, welcome, and the floor is yours, please.
Thank you very much, Marta, and very warm welcome to all of you. It's a great pleasure being here with you today and to show the single slide we produced to present our idea. We tried to compact it into 1 slide, and I hope we succeeded. So the real problem is that we see still an important gap between the plan and the execution of the plan, which basically leads into difficulties of allocating resources, be it infrastructure resources, be it human resources. This leads then to delays and to reactionary delays throughout the day, and will end up quite often into a night curfew violation, like the one project that we just have been heard previously. So we're just not focusing on night curfew, but really in the whole process as in its entire phase. So in terms of resources, we're thinking to be a bit more precise. We're thinking about the ground handlers, we're thinking about stands, we're thinking about gates, buses, border control. We also think about runway utilization. So today, if you look at the graph, it's probably a bit small, but you see in red the schedule, which is the initial plan. Then generally we get an adjusted forecast, day -1, and what really happens at the end is sometimes quite different. And this is obviously not ideal to optimize resources. Now, one could think that with COVID and low traffic, this is no longer an issue, but actually it's the contrary. Everyone is trying to save cost and puts resources on leave or on short-term work. So scarce resources are actually even more of a problem in terms of human resources. At least in Geneva, we also have an infrastructure problem because we have so many airplanes that are on long-term parking, so that actually you do not really have more resources than during normal operations in terms of infrastructure. So that's where it's really helpful. Ideally, we wanted to launch the idea to start at day -15, but we think in order to scope the initiative, we should probably rather go to the day of operation itself. Now, today, if we want to have a precise update on a specific aircraft, we can actually search for it on the private no portal, but it's flight by flight. Now, having 30 days, 30 flights a day in COVID, this is maybe feasible on a very low day. However, if we're getting back to a bit more regular operations, obviously the individual tracking, manual tracking is no longer possible, and we already do have actually at least a few days where we have quite more traffic. So the idea would be to have a regular update on the actual information EUROCONTROL has on the various flights. Ideally, obviously, we would add on passengers. We can do that in our airport operations center with our partners, and so this would also allow to update the resource planning, which are really passenger driven and not aircraft driven. And by doing so, we will be able to optimize our own resources, but also, and more importantly, our partners, ground handlers and airlines will be able to adjust their resources and their plan in order, as I said, to obviously save money, but also to avoid night curfews and broken rotations. So the central point where we deploy would be in the airport operations center, where all of our partners on the site have access. And as I said, mainly by a B2B exchange, frequent exchange of the latest flight planning from EUROCONTROL. If you have any questions, I'd be happy to answer.
Okay, thank you very much, Giovanni. So that's a very interesting proposal that you did during this ideation process. There was some other stakeholders that were show an initial interest, at least, to participate to this challenge. Some other airports like Berlin and Dublin, but as well airspace users like Ryanair, Swiss and Welling, and I was as well showing some interest. So that will be a part of the next phase for this idea. Thank you very much, Giovanni. So we can go now to the second presentation for the airport stakeholders. It will be done by Avi Chaco, which is who is the head of innovation in Gatwick Airport, and he will be presenting us the aviation data corridor proposal. Avi, the floor is yours. Thank you.
Thanks, Marta. Next slide. Today, when we want to exchange data between airlines, ground handlers, and airports, we have to rely on point-to-point interfaces. So whether it's an airline changing aircraft or the airport informing the airline about the gate allocated, or the PRM, actual PRM volume coming from the ground handler to the airport, or even the expected passenger volume or planned passenger volume coming from the airline to the airport. All of these things are exchanged through point-to-point interfaces. Sometimes, we use industry standard definitions like AIDX or ACRIS as a protocol to exchange data, but still it's a point-to-point implementation. Sometimes it's exchanged through Excel sheets and Word documents, etc. So and because of the cost associated with such point-to-point interface implementation and the time it takes to do that, sometimes we compromise and operate without that data or with some historic data references, etc. So that's the situation now, but this idea is about transforming that situation into a much more streamlined, common data sharing platform called Aviation Data Corridor. You can see that on the right-hand side, where each aviation entity would connect to that platform once to share all the data, and then decide which other entity should get the data through a control panel without having to implement point-to-point interfaces to each, every other aviation entity. So that is the concept. So this innovation is about doing that transformational piece with the support of aviation entities who are interested in seeing a platform in operations. Now, what are the advantages, or what a bit more details about that? So this would be a no-code platform for aviation sector for operational data sharing. What I mean by that is that you don't need to rely on technical resources to program a point-to-point interface to exchange data. Once it is integrated you can decide what data needs to be shared through configuration. So each access and distribution to each data element to be controlled by its owner. So for example, if it's Gatwick sharing the data, we can decide this data should be available to all airlines operating at Gatwick, or this data should only be available to EasyJet, or this data is available to all airports in the UK, etc. So you can structure the data access with a bit more logical rules, and all the other parties who come under that rule will automatically get the data. Obviously, assuming that those entities are also connected to the same aviation data platform. We could avoid some of the data that we are exchanging using type B messages. We can avoid that if we reroute it through this. And again, we can avoid the cost of implementing multiple interfaces. I think if we work together, we can, and if we use the latest technologies, we can actually build it at low cost, and we can probably make this available free as a with a basic functionality, and then we can recover the cost of implementing a system like this from advanced services or premium services. For smaller airports, a platform like this can straight away act as a AODB. They probably don't need a separate AODB. Also, something like this can quickly enable data access for third parties. So, for example, if we know that there is an AI company out there who can actually do wonders with the data, it only takes an exchange of key between you and that AI company to share the data. You don't need to implement a separate interface for them. You actually exchange the key for a period of time, and then they get access to the data, and they can analyze it, they can run their AI models, and then give the result back also for your use using the same platform. So, if I draw parallels, you have the credit card networks in the financial industry. You just use the credit card, and the money gets exchanged between your account and other people's account, and there is a network behind the scenes which make that happen. In the publishing industry, you have the content distribution. So you can see inspirations, you can draw inspiration from other industries for something like this. So once again, this is about creating something that is common, shared across multiple aviation entities in a low cost, and it can be implemented using latest technologies and can be delivered at a lower cost for everyone to use and everyone to benefit. And this would accelerate further innovation as the data becomes easy for all parties to access. Thank you.
Thank you, Abhi, for this presentation. Yes, I'm sure that will be interesting, so for you in Gatwick, but for sure in many other airports as well. So you saw already the interest of maybe some other airports in the stakeholders group like Berlin and Milan. But as you said, it might be interesting as well for some other stakeholders, and there was some airspace users that were as well interested in this idea, like Swiss, Transavia, and Vueling. So looking forward seeing this project progressing. Thank you very much.
Thank you.
Okay, and let's go now to the last idea for the airports. And here it will be Giorgio Medici, who is the director of the environment and the airport safety in Milan Airport. He will be presenting us the idea with respect to preventing runway excursions. So Giorgio, please, the floor is yours.
Thank you very much, Marta. And first of all, really, we are appreciating this opportunity to be on board on this kind of initiatives, which is bringing innovation so close to the real needs on one hand, and on the other hand is also provide opportunity for airports which are suffering such a difficult situation now in investing resources in innovation. Okay, what is the challenge that we are facing, and we decided to submit as a project? When we speak about runway incursion, we have to look at two issues for airports. One is the responsibility that the regulations are bringing up to the airports in terms of safety at the airport. And we as airport operator are requested to control, to prevent, to invest, and to do actions to prevent issues which can affect safety. And runway incursion are, of course, one of the most relevant and dangerous issues that we have to manage. The other point is that when we speak about preventing runway incursion, as airports, we are speaking often about solutions which includes capital-intensive solutions. I just mentioned what are the runway status light solutions at airports that we are asked to build some when we see specific configuration of runways, or even the advanced runway incursion warning systems that are now in some airports in Europe. And the point is, what is the value of such solution, and what could be the decisions that bring us, what are the elements that can bring us to take such a decision? When we perform risk assessment, you see that what we want to do is to build a platform, a basis to support all the airport in risk assessing the issue of runway incursion. When we do risk assessment, we need data. We need historical data. We need trends. And thanks God, locally, data about runway incursion are a really poor amount of information that we have. So the point that the idea is to build and to support the development of we call the secure anonymized database. So to have information about runway incursion without compromising confidentiality, so also supporting the no blame approach to safety, of course, but also to build a safety intelligent tool to identify precursors to runway incursion. The idea is also to involve the EUROCONTROL, the resources, expertise of EUROCONTROL, to support airports not only with data. At the moment, data are not shared, not easily shared about these issues, but also find the way to build a model that can help airports to identify what could be the precursors situation that can bring to potentially to runway incursion. I just mentioned one point that it's not an issue of amount of traffic. What we are experiencing in the last year, 2020, is that the events are not decreasing as much as the traffic. So not only a high amount of traffic can bring to a higher possibility to have runway incursion, but also the strong decreasing in traffic, and so low operation in the airport where usually we have heavy operations and a large number of operations, can be an issue for runway incursion. So the point is, if we can build up data sharing and also a model to address the issue, we are convinced that we can provide airports and NSP as well all the information they need to take the right decision for each specific situation at airports according to the usual conditions they have to face at an airport, weather, not weather, heavy weather condition, winter operation or whatever, or just the configuration of runways. So we think that we expect to bring something that can be really of value. We are not sure that how far we can go with the project, but this will be indeed a very good opportunity to try to do a common effort about that.
Yes, indeed. Thanks a lot, Giorgio. It's true that runway incursions is one of the important risks that we have in aviation. There are several initiatives and several activities already ongoing, but there is still the need of doing some more. So I think that that would be very interesting to see the outcomes of this project within the Innovation Hub and to see which are the benefits that we can get from these ideas. As I mentioned for the other activities, ideas, for this one as well, there are some other stakeholders that already express their initial interest, at least for taking part on the scoping part of this idea, like Dublin, but as well Air France and Ryanair. But I'm sure that there's many other stakeholders that may be interested in the outcomes of this project. Thank you very much, Giorgio.
Thank you, Marta.
Okay, so with this one, we finish the ideas related to the airports. Now we are going to start with the ideas that were proposed by the airspace users. And the first one that we are going to present will be the digital 80s. It will be Laurent Lafontaine, which is the Air France Flight Operations Technical Director, who will be presenting it for us. Thank you, Laurent. The floor is yours.
Thank you. Hello, Marta. Do you hear me? Okay, perfect.
Yes, we can hear you.
That's great. Okay, so I'm really happy to be with you today. I know that Mathieu Durand-Gobert already talked to you about this subject. For airlines, we see several benefits, whatever it's at the stage of flight preparation or during flight monitoring. Few issues, flight safety issue with better situation awareness of weather and operational condition. For example, the runway is closed or not, and the same thing about taxiway, and having the same information for pilots and dispatcher. Actually, dispatcher don't have access to all ATIS. So with this technology, dispatcher will have access to ATIS. So for this, we can see there is a flight safety issue. We have simplification and dematerialization issue, providing information on the weather application without the need to go through the AKS. And the last one, it's challenging about fuel savings through better awareness of runway in use and taxiway configurations. So as we have already explained, the technology to be able to use it would be to use the NOP of EUROCONTROL, the Network Operational Portal, and to be able to take the information from the source with an application programming interface. So for all this reason, I think it's very interesting for airlines, for simplification, for safety issue, and for our fuel consumption program to be able to do this talk about this ATIS technology. Excuse me. For me, that's it. I just wanted to thank very much EUROCONTROL and in particular Laurent Renou for creating this opportunity for a lab and collaborative work. Air France, we are really very happy to participate to this initiative, which allows us to put EUROCONTROL, air navigation service providers, ATC, and airlines around the table in order to have innovation and concrete action that will improve our operations. So thank you very much.
Thanks a lot, Laurent. Indeed, this is one of the purpose of this Innovation Hub, to put together the different stakeholders and being able to share proposals, but as well getting the benefit of the outcomes of these proposed ideas. So it's true that for this proposal from Air France, there are many other airspace users that has already shown an initial interest to participate, like Ryanair, Swiss, Transavia, Vueling, and AOPA, because they see the benefit of having this kind of ideas put in place. So again, looking forward, seeing the scoping phase for this idea going on, and then the rest of the development of the process, and to be presenting the results as well to the rest of the community. Thank you very much, Laurent.
Thank you very much, Marta.
Okay, so let's go now to the second idea proposed for the airspace users. In this case, it's from the AOPA, and it will be Michael Erb, which is the Senior Vice President of this association, and will explain and present us the idea that they call better support for general aviation flight planning. So Michael, please, the floor is yours, what you want. You have to unmute yourself.
Thank you very much, Marta. Good morning, ladies and gentlemen. It's my pleasure to introduce to you this proposal for general aviation. And in this context, we use the definition of general aviation in its widest sense, including, of course, all air sports operations, business aviation, rotorcraft. And what we want to propose is a better system for NOTAMs and flight planning. To give you an idea about the magnitude of the issue, in Europe, we have about 100,000 motor-powered aircraft operating as general aviation, and they conduct at least 10 million flights per year, and all of them need to be planned safely and also efficiently. The NOTAM briefing is required for all flights, and many flights, IFR, cross-border, require a flight plan. And pilots are operating very often on their own. They are not having the support, as in the airlines, of a dispatch department or an AAS facility on site. They very often get access somewhere on the apron through a cell phone or a tablet computer to the system, and it's very often a challenge. NSPs are very supportive indeed. They offer access to NOTAMs and the filing and management of flight plans on their website, but this service is very often restricted to national airspace, requiring multiple registrations across non-standardized systems, especially causing difficulties on international flights in Europe. And there is unfortunately no European one-stop shop for NOTAMs and flight plans. And there is aeronautical app providers on the market that are offering NOTAM briefings and flight plan management as a paid extra. But unfortunately, they often refuse to take liability in their fine print for the correctness of the NOTAMs. And for us, access to safety critical data should be facilitated, and the provider should take liability, as failures, of course, they are posing risks to the users and even to people on the ground. And because of the difficulties to get access to a NOTAM database, some pilots indeed are reported to have taken out without NOTAM briefings. In most cases, it does not matter, but in case they infringe an airspace they are not aware of, then this is indeed something we do not want to happen. Now we are seeing the problem, but of course we are also having the solution, and that would be development of a NOTAM and flight plan app. It should run on tablets or mobile phones, providing all relevant NOTAM information for flights and routes, using filters and advanced algorithms to facilitate easier access to the right NOTAMs. Typically, if you would print out a NOTAM even for a short VFR flight, that's 20 pages. And you can apply filters, but if the providers are not taking over reliability for filtering out the right ones, then you're having a huge problem somewhere on the apron, trying to filter out what is relevant for you. If you ever had to deal with NOTAMs, it's yeah, very difficult to read. And some people were making jokes already that the next step of complication would be to use an enigma to make it more encrypted, but we want to go into the other direction to make it easier understandable. The improvement would be to facilitate access to NOTAMs with an app, and it would significantly increase the safety for pilots and all other airspace users. And it would make the filing of a flight plan easier to avoid having to file a flight plan in the air. This sometimes happens, and of course this would make the flight operations safer and take away a lot of unnecessary workload from the air traffic controllers. And information in the planning phase of a flight about accessibility of airspace would of course also allow more direct routings and reduce the ecological impact of a flight. So this is a point which I'm raising here last, but definitely not least. That's my presentation, everything on one slide, and I hope
Thanks a lot.
could bring my message across. Thank you very much.
Thanks a lot, Michael. Yes, it was very clear. It's indeed a quite challenging idea as well. But I think that this is a little bit the purpose of the Innovation App as well, to have in front challenging ideas, and as well supporting the aviation in general. So general aviation is part of it. So I think that it's important to have ideas coming from your community as well. There are some other stakeholders that were interested as well on this proposal, like NIDE, for example, and Swiss. So there will be the opportunity to share experiences and try to find solutions to this challenge and problems that you present. Thank you very much, Michael.
A pleasure.
Okay, so we can go now to the last part of the ideas that refers to the air navigation service providers. So we are going to start this last part of the presentation with Guillaume Blondel, who is the Operations Director in DSNA. He will be presenting us the idea on green management, optimizing arrival flows for green operations. So Guillaume, please, when you want, the floor is yours.
Okay, thank you, Marta. Good morning, all of you. So as Marta told you, my name is Guillaume Blondel, and I'm the new CEO of DSNA since the beginning of this year. And it's, of course, a great pleasure for me to participate to this first Innovation Hub event of EUROCONTROL. And thank you, Laurent, to invite me. I'm convinced that the innovation, as Aaron said as an introduction, I'm also convinced that the innovation is the only way out for our sector to meet the challenges of the coming years, which will be, of course, digital and greener. And greener is one of the main goals of the project that I will present you now. So, of course, I also would like to thank EUROCONTROL for having chosen this project in this second round. And for the DSNA, the recovery of traffic must be accompanied by a logic of ecological transition. I think for us, it's the main goal, of course, after safety. And the acceptance of our activity will require a better consideration of environment topics in the coming years. And we are already convinced of that. In the past year, we have all worked to put in place tools to help ATCOs to improve the capacity of the network. And the goals today are quite different, and we must therefore now provide decision-making tools to make the most environmentally responsible choices. And that's it. I think it's the main difference between the past years and the next years. It is for this reason that today we are looking for technical solutions which make it possible to bring decision-making tools next to the control position. The goal of this project, be sure we only have one slide, that won't be long. The goal of this project is therefore to move forward step by step, according to an MVP process, of course, and also agile, and to bring value on the control position as quickly as possible. And we want to implement a tool making it possible to present a management strategy of the arrival based on CO2 and minimum noise, and not only based on optimization of capacity, which was the case before with the airman, arrival manager, for instance. So as we currently have a tool for optimizing arrival, as I told you, is airman, according to different strategy, minimum taxing or no crossing. During the peak hour, we use the strategy of no crossing, and during the low traffic period, we choose the strategy of minimum taxing. And we think that we have to also introduce an environmental dimension in the criteria for allocating the runway. For instance, today, traffic coming from the north is the northern runway is allocated for the traffic coming from the north during the peak hour, and we think that sometimes it could be better to allocate the southern runway, or maybe sometimes it would be better to look at the northern runway, even if the traffic has to taxi to the south. And we never take into account the environmental dimension and the CO2 emission in our criteria, and I think we have to move forward to this new criteria. So as we currently have a tool for to develop these tools, we are happy now to be able to rely on the initiative from the Brétigny Center, and we also need to gather on board an ATC data to refine our analysis model. And I think that's why we also have to a different partner to bring that data. And I don't know if we can call it IA. For sure, it probably sounds modern, but the main thing is that data consolidation allows us to refine the model. Of course, one of the main goals is to deliver value quickly. That's why we decided to work on the basis on the first use case, which is very simple, but with significant added value regarding the environmental criteria. We think then to deploy this type of concept, also on more complement concept. For example, the question could be, isn't it more judicious to make a high altitude holding pattern rather than to lengthen the trajectories in the TMA? We can also imagine to manage the flow of departures from CDG, but also from the peripheral airports like Beauvais or Le Bourget, and on the same concept and with the same objective, reduce CO2 emission. So as you can see, the proof of the concept can be made and tangible KPIs can be demonstrated. We can build the roadmap of the product, but still step by step, and the goal should always be to deliver value quickly for our customers. That's all for that, Marta. I hope that you understand the main goal of this project. And thank you for your attention. And if you have any questions, I'm listening to you. Thank you, Marta.
Guillaume. It was very clear, and I'm sure that in the coming month we'll have much more discussions about that. As you said, this is something that we need to include some other stakeholders in it. There was some others ANSP that show interest, like NIRE and NATS as well. You were talking about data. This is important as well, that maybe you can share this kind of information between you to make this prototype. And I'm sure that not only safety is taken into account, but environment as well. So yes, there's as well airspace users interested in this idea, like Air France and Swiss. So I think that it's a good, let's say, group of stakeholders that can contribute with the different perspectives to this idea. Thank you very much, Guillaume.
Welcome.
Okay. So let's go now to the second presentation in the group of air navigation service providers. And in this case, we are going to have Dave Curtis, which is the director of the Airspace and Future Operations in NATS. He will be talking to us about the improved trajectories to support arrival management and other operations. Dave, please, the floor is yours.
Thank you very much for the opportunity, and like some of the other speakers have said, and like the comments we come through, I'd like to thank EUROCONTROL for the innovation labs and being involved, and certainly from a NATS perspective, we certainly welcome the best way of actually getting things from innovation into implementation is important as well. I'm just going to cover a little bit. We've picked up quite a snappy title there, not really. But this is about improving trajectories. Realistically, that's what we need to be able to do, and actually linking together the capability that's in the aircraft and the capability that's on the ground in a far better way. Really complementary as well to my colleagues from DSNA about the fact that this is for an significant environmental improvement we could see that is. Going back to basics, I suppose, and that's what we said within the context here in the problem statement, is that we, as of today, most of the modern aircraft have the capability to very accurately meet target times over a waypoint. But actually, what we don't do is have more information, if you like, of the earliest or the latest ETA. So not all modern aircraft can share that. The other side of the coin as well, from a ground-based perspective, and certainly in things like AMAN and Arrival Manager, we use ground calculated ETAs based on data that's coming from ETFMS. And it's the accuracy of that data from ETFMS that we want to actually improve significantly, because then we believe that we'd be able to issue target times to aircraft that are more achievable for them to be able to fly. By issuing those target times for the pre-departure point, as it says there, we'd enable the aircraft to arrive at the descent phase self-streamed. So instead of a controller intervention or controllers getting involved, we'll be able to have self-streamed aircraft enabling more continuous descent, more accurate arrivals over the arrival point, and ultimately significantly removing delays. That is based on having accurate trajectory service, accurate data. For the into the AMAN, the arrival manager machines. If we can enhance that as well with the actual speeds that aircraft to fly, rather than sort of models, we can then issue those target times to arrivals, target times to the pilot, tailored to accurate speed, so that we know that there's going to be a certainty of arrival, rather than using the generic model, as I've said there. The potential benefit that we can get at reducing controller workload, reducing complexity for pilots, giving certainty of arrival, it could be significant. Ultimately, as well, the traffic will be back. There will be a lot of aircraft back as we come out of the pandemic. And what we want to do is reduce that bunching, particularly if we link that the fact that there are the 18 airports that have to have arrival management. The size and scale of the benefit, and this is just one example, and obviously it's just an example of the way we put, but since 2015 we've used X-Man procedures at Heathrow. They've been based on they're quite generic in terms of modeling, but ultimately the benefit that we've seen has been huge. So that's per year we've saved 8,000 tons of fuel and 120,000 minutes of holding delay have been removed. So we see that if we can relay that across lots of different airports, then there's a huge significant benefit here. And it's all based on having accurate data, working with EUROCONTROL and the airlines to be able to make sure that we can do that. And the environmental benefit could be absolutely huge in that, and of course potentially capacity increase as well, because of reduction in controller workload. So we thank you for the opportunity, as I've said before, but realistically we would like to work on getting this into service as quickly as we can. Thanks very much.
Thanks, Dave. So yes, indeed, as you said, we are in a period in which traffic has been slowed down quite significantly, but this is the opportunity to put in place the things that will allow us to afterwards take into account that the traffic will come back and to improve things. This is one of the proposals that I think goes in that direction. And there are some other stakeholders that already express interest on this idea like DSNA as well, but Milan Airport was interested on that as well as the Air France and Swiss. So I think that yes, putting together all these different stakeholders can support the development of this idea. So thank you very much, Dave.
Thank you.
Okay, so let's go for the last presentation, but not the least interesting one, of course. This one will be presented by Xavier Nevenaven. He is the NAIRE Operation Director, and he will present us the knock-on delay visualization. So Xavier, the floor is yours when you want.
Thank you very much, Marta, and good morning, everyone. First of all, I'd like to thank EUROCONTROL and the organizer team for allowing us to be here today presenting our project. It's an honor to be here, and I'm very, very grateful to share it with all of you. Before getting started, I'd like to echo what Eamon said at the beginning. Regarding the overall scope of the projects we are addressing here today, even though they are under the innovation category, they are designed not only for the long run, but for the short run, providing specific solutions for specific problems. And I think that this is paramount to succeed in this initiative. So in our proposal, we are trying to address both issues, the short run and to solve specific problems. As you can see on the slide, this solution will pave the way for a better network management of delay generated at one or many hub airports of the network. When it happens, when there is a delay, there's a need for all operational stakeholders to immediately be aware of the problem and to visualize as soon as possible the consequences and the magnitude of the issue. The visualizer we are presenting here today should be connected to the what-if capability in the airport's operation center in order to see the effects of the proposed or already implemented measures. Saying that, the proposed system provides the basis for an early warning system. And I'd like to highlight this sentence. This is an early warning system that predicts the impact of knock-on delay in a hub airport. As you see in the slide, the benefits of the tool will be for ANSPs, for airports, for expert users, and of course, for network manager. It will not exactly reduce delay, but it will allow for a better management of the generated delays in other airports of the network. The technical side, this is based on supervised machine learning and data mining, and it addresses the communications using the V2V capacity, the technology V2V, connected to all of the FMPs in the ops room. So thanks to having a better visualization of what's happening in the affected airport, the rest of the network will have a lot of benefits. And in order to be brief, and finally, I'd like to highlight that this project directly links with the joint initiative between SESAR and EUROCONTROL to connect regional and small airports to the network manager services. It was an initiative that was presented in the last UNDOP and detailed joint session 2 weeks ago to address the problem of uncovered departing traffic from these small airports. This is not a minor issue. We have to take into account that by the end of 2021, it will still represent 41% of the total departing traffic. That's the traffic departing from small or regional airports. Then with this tool, the knock-on delay visualization solution, the benefits will not be exclusive to the main stakeholders of the European network, but also to the users and managers of these small airports. So this is an overall solution. That's what we think. Marta, that's all. It's an exciting project, very challenging, and thank you very much. Back to you.
Thanks to you, Xavier. It was very clear, and yes, I think that it is interesting as well for many other stakeholders. Some of them already saw the benefit of this idea, in particular some airspace users that would like to be involved in the scoping of this project. Like Air France, Ryanair, Swiss, and Vueling. You have the collaboration as well of AENA. So I think that this is a very important point to put people together around this idea. And yes, let's see for the next cycle too, what the outcomes will be for this project as well. Thank you very much. So just to finalize this morning session, here you have again all the ideas that has been proposed. This is the official launching of the cycle 2. So just to thanks again to all the speakers and all these interesting ideas that they present. They will be running for the next 6 months and just looking forward the outcomes of them. So Laurent, I pass the floor to you now to conclude this morning's session. Thank you.
Thank you, Marta, and thank you for the 8 speakers. So thank Giovanni, Abby, Giorgio, Laurent, Michael, sorry, Guillaume, Dave, and Xavier. So thanks a lot for your presentation. And so as Marta was saying, now we are going to, so it's time to launch this second cycle. So what is actually coming next? Now for these 8 operational challenges, time is to scope this activity. So first to understand the problem, to refine the problem, to know exactly what needs to be done, how long it will take. It might take more than 6 months again. It could take 12 months, 18 months, and then. But if it takes more than 6 months, how we could split this project in pieces in order to already deliver something in the next 6 months. So the next few weeks we will understand and refine the problem, first point, and also on our side and with you, we will set up the team. So Marta already mentioned so the name of the operational stakeholders that will be pleased to join this any particular project. But of course, and that was the opportunity of this promote event, it is open to any operational stakeholders. So as another operational stakeholders, not as the 30 that has been presented, if you are interested by one subject or more than one subject, please contact us, and then you could join this initiative and join one subject that is of interest for you. So that's what will come next for the second cycle, the next weeks, to scope this activity for each of the 8 operational challenges. Now, let's plan for even the future, and just to also for the operational stakeholders involved, but also for the ones that were not involved in the second cycle, just to give you some look ahead, that the third cycle will start in 6 months from now, so in October. And in mid-October, we'll have the same event, another promote event that will be the second one, where we will present the result of the second cycle, and also we will launch the project for the third cycle. So September, that will be time for you, the end users, to propose projects, propose challenges, and then you will prioritize them as we did, for the second cycle, and we will select the one that will be, retained for the third cycle. So that's what will come next for the third cycle. So please be ready, but because it will be very quick in September to submit operational challenges. So that's all for this morning. Now, thanks again for your participation. I could, roughly quickly present you the agenda for this afternoon session. It will start at 2 p.m. and then we'll go in technical details of the 3 solutions that has been presented to you this morning. So thanks all for your participation, and so looking forward to seeing you at 2 p.m. Thank you. This afternoon session, we are targeting the technical stakeholders, and for each of the 3 projects from the pilot phase, pilot case that run from September to March, we will present you how we achieve the result that has been presented this morning. But before going into the detail of this afternoon session, let's remind you the objective of this innovation initiative as it has been presented already this morning. So first, it is open to all stakeholders, as Imon stated clearly this morning, and we will address the end user needs from ANSPs, airport and airspace users, and we will develop digital solutions. We would like to accelerate the market uptake, and as has been said already, to streamline from innovation to deployment, industrialization and deployment, and will target short-term operational improvement. And we would like to complement the SESAR program, bringing agility into the SESAR program. So we will develop at EUROCONTROL a Brétigny innovation hub, where on one side we will partner target with the end users, ANSPs, airport, airspace users, and on the other side we will partners network with the research center, the university that will help us to develop the digital solutions, this prototype. So now in terms of processes, innovation processes, so Dirk, if you could, thank you. We decided to combine our expertise with the agility that is needed for such initiative. So a 6-month cycle, and first to connect, so to collect needs from the end users and to select the project that will be retained for this operational, for this innovation initiative. And that's a way to create this European network approach. Then the build phase, where we will address the end user needs and develop the prototype, this digital solution. And last but not least, this promote. So the promote event like today, I'm glad that we are going to share. We already shared this morning the operational result. We are going to share with you the technical result. And it's also time, as you know, you saw it this morning, to launch the next cycle. So last but not least, now we actually, for this innovation initiative, we already launched a pilot phase last summer. So we work with 7 airlines, so Air France, EasyJet, Ryanair, Swiss, Transavia, Vueling and Wizz Air. We work as well with Paris Orly Airport and with the EUROCONTROL network manager. Why? Because we wanted to be very pragmatic, to start small, to learn by experience, and to grow gradually. 12 projects has been proposed by the operational stakeholder last summer, and we selected 3 of them. And now it's time to move to the technical solution for the 3 operational projects. So operational challenges. So Dirk, I will give you the floor now to introduce this afternoon session. Thank you.
Okay, thank you very much, Laurent. Good afternoon and welcome back to those of you who have attended the morning session. It's a delight for me to be your moderator this afternoon, and I want to start by complimenting the speakers from the morning session for the excellent presentations, which I found very, very interesting. Now, this morning we introduced the 3 Innovation Hub projects that were launched in the pilot phase, and we got the view from the operational stakeholders perspective, the customers, if you like, of these projects. This afternoon, we would like to give you a little bit more detail. So the 3 projects will be presented by the team that worked on the project leaders and some of the experts who've done the work. And most of these experts are from the EUROCONTROL Experimental Center here in Brétigny, sometimes complemented by some of our colleagues in Brussels. We have a 30-minute slot for each presentation, which we will use roughly for 20-minute presentation plus a 10-minute Q&A session. We're live streaming on YouTube and LinkedIn, and I think on YouTube there's the opportunity to ask questions, and our colleagues will hand these questions back to me. Depending, of course, on the number of questions that there will be, we might or might not be able to address them all. We will see when when we come there. I would like to hand over to the first team, but before doing that, give you a little bit of detail about how to use Zoom. Now, those of you who've attended the morning, which I think is the majority, have probably figured out already that we have a chat and a Q&A panel that you can use. Please use the chat for technical problems or anything not related to questions. Use the Q&A for the questions. And please, if you do so, type the name of the person whom you would like to ask that question into the question, because we might address these questions after the presentation has already finished and we moved on to the next presentation. We might still be answering the questions. So it's always good to know who is addressed by that question. The chat also, the Q&A also has a feature which is called upvoting, which is a little like Facebook-like. So if a question is in the Q&A stack, which is similar to a question that you would like to ask yourself, rather than typing it in again, you can just upvote this question. It moves up in the stack, and the questions on top of the stack are, of course, the ones that I will be starting the Q&A session with. The presenters can also answer the question in typing, which means that if you have posted a question and it has not been answered in verbally, check back. However, still it might be addressed in the in typing, and in that case it will move into the answered question category, so it will disappear from the open questions. And with that, I have the pleasure and privilege now to hand over to the first project. The first project, and I will stop sharing my screen so that the project can present from their own computer. The first project is prediction of waiting time at arrival, and it will be presented by a team of 3. Karim Segal, who is the EUROCONTROL project manager, Bruno Favenek, who is an ATM expert here in the experimental center in Brétigny, and his colleague Raphael Christine. And I hand over the floor to Karim.
Thank you, Dirk. Thank you. Good afternoon all, and thanks for joining. Yes, I think we are ready now. Before I leave the floor to Bruno and Raphael, I would like to insist that we were all on board. So there have been 3 other contributors. I think Bruno is okay. Maybe you can go on slideshow. And small technical stuff, I hope. So we have Emeric, Kerik, and Jérôme also who contributed. Yes, it's okay. It's okay, Bruno. Up to you now. Thank you.
Bruno, you're muted.
Thank you. I had some small problems. Sorry about that. So the today actually the fuel planning processes do not take into account in a very accurate manner the weather at destination, and this tends to result in sometimes too conservative fuel strategies. So we addressed this problem with the participating airlines in this InnoLab project, namely Air France, EasyJet, Ryanair, Swiss, Transavia, and Vueling. The idea is to predict waiting time in the terminal area at destination to support the fuel planning. This waiting time is actually the requested additional time to cater for sequencing, metering, and when needed holding. And the prediction integrates weather, but also traffic demand. We focused our study on the pre-flight phase for intra-European flights, which means about 1 hour flight time, and predicted the likelihood of having a small, less than 5 minutes, moderate, between 5 and 10 minutes, or high waiting time for 30 minutes time periods. We did that for the dispatch and the flight crews. The dispatcher needs that information about 4 hours before departure. That is to say about 5 hours for 1 hour flight time. And the flight crews 2 hours before departure, i.e. 3 hours for 1 hour flight time before arrival. We looked at 4 congested airports: London Heathrow, Dublin, Lisbon, and Zurich. And indeed, one can expect that when you operate close to congestion, then the weather impact is more important. So this is typically a classification problem. We have to predict the probability to belong to a given class of waiting times. And we developed a machine learning model taking as input historical data from 2013 to 2019. The model uses the time and date to current waiting time at destination, but also, as mentioned earlier, the traffic demand and the weather. And the output is for 30-minute time periods, the probability of having a waiting time in one of the 3 classes, 0, 5, 5, 10, and plus 10 minutes. You can see on the right-hand side here, the type of output. It's actually a series of 3 probabilities for the waiting time to belong to each of those classes. The interest of this kind of output is also that it gives a kind of a confidence index. For instance, if you have like here a high probability for one of the classes, you can be quite confident about your prediction. If you have similar values for the 3 classes, of course, the confidence becomes low. We had a separate model calibrated for each of the study destinations and for each of the prediction look-ahead times. And initially, we used weather observations, that is to say METAR, in order to discriminate the model performance that we tested against from the weather prediction accuracies. In addition, we developed a statistical reference to be able to benchmark the various versions of our model. And this statistical reference takes in as input the time and date, the quarter for seasonal variations, and it gives a statistical output of waiting time in the 3 classes. Talking about statistical reference, actually what we did is that we used this historical data from the network manager, and we constructed or calculated the additional times, the waiting times. In order to have our reference, we consolidated these values on the days of the week, the quarters, as I said. But of course, this database of waiting times can be used in a different manner. So we can consolidate it on various periods of time. And for instance, here we have a view of, I believe it's Dublin for March. So we have consolidated all the days in March. On the x-axis, you have the time of the day. On the y-axis, it's the waiting time. The green curve gives the median value along the day. The yellow, orange, and red curves give the 19th, 98th, and 99th percentile. So as you can see, we can have a variety of displays from this database, which is quite interesting. I will now leave the floor to Raphael to give you more explanations on the challenges on the model development and on the model performance.
Okay, thank you very much, Bruno. So you just saw waiting times at arrivals at Dublin on a given day. And of course, we didn't look just at waiting times on a given day, we just looked at the waiting times on the full data set. And we observed that for all destinations, but London Heathrow, small waiting times are frequent and large waiting times are pretty rare. And this is what you can see on the bottom right graph. For Dublin, in more than 70% of the cases, the waiting times were lower than 5 minutes. And in only 8% of the cases, the waiting times were greater than 10 minutes. This means we've got a pretty imbalanced data set. And if we don't pay attention, we might think our machine learning model has got good performance, while actually it might perform poorly on the moderate or larger waiting time cases. Another issue we have with such an imbalance is that we've got a limited sample size for the larger waiting time cases for which the machine learning model will have to learn from. And we have a bit of a similar issue with weather. Weather is good most of the time. By that I mean that in 80% of the cases, the weather has no impact, no significant impact on the terminal area capacity. So that's a good news in terms of operations, of course. But again, it means that for the machine learning model, bad weather cases are more rare and the machine learning model is less exposed to those cases. So this asks the questions about data availability. We need to have a great quantity of data so that the model can see enough of the large waiting time cases, enough of bad weather cases, etc. And it's not only a question of quantity, we also need this data to be reliable so that what we are learning is correct. Another thing about data availability, we started to add as an input for our models unexpected airport events. But we know that it's not a complete data set that we have today. So it means that the performance of the model might also be impacted by the fact that we don't know that some unexpected events are occurring. Finally, I'd like to mention also that we saw that in some cases, you can have one situation with a given planned traffic in 3 to 5 hours from now, same weather, same everything. And in one case, it can lead to a small waiting time at the end. And in the other case, you seem to have the same traffic, same weather, same everything, and you got a large waiting time at the end. So of course, for the machine learning model, it's a bit tricky because for the same input, you've got different outputs. You've got an overlap there. It's kind of blurry. One of the reasons for this is that we've got takeoff time uncertainty. And in some cases, you'll get a smooth traffic flow at destination, leading to moderate delays. And in some cases, you'll get traffic bunches that might lead to larger waiting times. All right, so you've got an idea about some of the challenges ahead. So we can now see that we can design the models. So we've been using typical open source machine learning tools. And then we've been running those models on the available hardware that we have at the experimental center. So yeah, we can see the next. Perfect. So once what we did, we actually calibrated, benchmarked a series of machine learning models from simple to more complex. And at the end, we kept a random forest model because it was the one with one of the highest accuracy and a very fast training time. And this model was calibrated using 6 years of data from 2013 to 2018. And we keep the full 2019 year to do the performance test. And this is what you can see on the graph on the right. On the x-axis, the two first points represent the baseline. So this is the statistical reference Bruno talked about before. So it's not machine learning based. And all the other points on the right, all the random forest experiments are listed there. So a series of tests and trying to improve as we go by iteratively on that model. On the y-axis, we've got the performance going from 0, very poor, to 1, which would be just perfect. And you've got one curve for every destination. So what do we see on that graph? First is that the baseline performance is in the range 0.3 to 0.4, while all the models have a performance in the range 0.4 to 0.5. So it's higher than the baseline. So that's good news. The machine learning beats the baseline. What we can also see is that all the curves are not overlapping. So we don't have the same performance for all destinations. For example, here we've got a better performance for London Heathrow than for Lisbon. One of the likely reasons is that we've got much more cases with larger waiting time for London than we have for Lisbon. What we can also see on that graph is that even if we try to do some iterative improvements, we really have a performance plateau there. So it's kind of stopping between the 0.5 arena. So that's about it in terms of overall model performance. But we would like to share with you probably a more user-friendly model performance metric. That's why here we will propose to look at what we're calling a waiting time error. So when the model does a prediction, it tells you something like there's a 70% chance that the waiting time will be between 0 and 5 minutes, and 25% chance that it will be between 5 and 10, and 5% remaining greater than 10 minutes. In that case, we will tell that the model predicts the maximum likelihood to be the 0 to 5 minutes case. And if the actual waiting time was 2 minutes, for example, then we will set the waiting time error to be 0 because we predicted the right waiting time range bin. However, if the most likely was 5 to 10 minutes and the actual waiting time was 12, then we will set the waiting time error to be 2 minutes. So the difference between the actual value and the boundary of the predicted waiting time range, the most likely one. So with such a definition of waiting time error, we can report it for both the baseline in purple and for the model in green. For the 0 to 5 minutes case, so when the actual waiting time is small, we can see that the baseline is nearly perfect. So it's simply due to the fact that most of the time, the baseline tells the waiting time will be small. So when the waiting time is small, indeed, the baseline is right. However, whenever the waiting time gets larger, moderate or high, especially if you look, for example, at the greater than 10 minutes box plot, you'll see that since the baseline tells the waiting time will be small, then it's getting wrong. We see that the median error here is around 4 to 5 minutes, while actually for the model, the median is much closer to 0, and the waiting time error range is also smaller. So the model beats the baseline for larger waiting time cases very clearly. Now we shall recall that the model doesn't only provide you with a binary view of the delay. It doesn't tell you it will be 0 to 5 minutes waiting time and done. It tells you it will be between 0 and 5 minutes with a 70% chance, or with a 30% chance. Or, for example, if it's highly confident with an 85% chance, then we observed, this is what's reported in the bottom right graph, that when the model is very confident, usually it's really accurate. So you can trust the confidence level when it's high. If it's low, of course, the accuracy is usually smaller too. Okay, so that's about it in terms of overall performance in a nutshell, aggregated figure. So now we'll try to have a more dynamic example now on London Heathrow on a Sunday. Okay, so here you can see a timeline on the x-axis from 9:30 to about 8 p.m. and on the y-axis, the waiting time in minutes. You can see also on the box plot the typical waiting time distribution, the statistical reference for Sundays at London Heathrow. So we can add to this information the weather. So here, if it's light, the weather is fine. If it's getting darker, the weather starts to get bad. And if you add to that also all the traffic input, traffic demand, all the model needs as input, then we can start to make a prediction. So for example, at 9:30, so we've got a vertical black line telling what the current time, we can do a prediction for 12:30, so in 3 hours time. This is what's represented by the box plot in dark purple. This is based on the likelihood of the different waiting time range that will build this confidence interval. And we can see that this dark purple box plot is not the same as the usual baseline that's below. It's higher waiting time predicted. Now, if we look 30 minutes later, it's 10. We've got a prediction for 1 p.m. And you can see that waiting time is still, again, continuing to increase according to the model. You can also see appearing a little blue line on the left of the 10-hour vertical line. It shows the actual waiting time. So at the end of the day, we could compare this line to the actual prediction and see if we were good or bad. So now we can roll some of the predictions we've made during the day. And as it's rolling, you can look at the blue curve and at the tendency, the overall trend of the purple predictions that made in the past. And overall, you can see that the trends are pretty well captured. It's not perfect. It's not exactly spot on the line, but the overall waiting time trend seems to be captured correctly. So now the question about how could this benefit to the airlines? I will let now Bruno show a bit more about this.
Thanks, Raphael. So as you said, we wanted to, from there, to start exploring the benefit mechanism. So we did a case study on a limited number of flights, 22 flights, using data from the participating airlines. You can see here on the diagrams, the output from the model. This is represented with the green histogram with the three values for the probabilities for the low, medium, and high waiting time predictions. You can also see the actual waiting time That's the blue vertical bar here. And you can see actually an estimate that is actually a waiting time back calculated from the fuel plane data for the flight, the dashed black vertical line. We had a number of cases like here, where we had a correct and confident prediction of the waiting time at destination. As you can see, the blue bar is in the low delay in all these cases, and also the probability is quite high. So it's really a case where an operator could use the value with quite some confidence. And then, as you can also remark, there is a significant difference between the actual and the correct prediction on the one hand, and what has been carried in terms of extra fuel for the flight. So in that case, of course, it's not statistically significant, but in that case, in those cases we had in our study, we can guess that there would be a potential for benefit there. On the other hand, we have a few prediction error cases, like the one on the right-hand side, where the waiting time was predicted incorrectly, with, in that case, a high confidence, a high probability for the low waiting time. And this is a kind of case that we need to further analyze. So this means this first insight actually is only to illustrate the potential benefits and benefit mechanism. Still, we need to go further on the analysis of those prediction errors, and also to conduct a comprehensive validation with the airlines to go further. So what are the outcomes of this project? What was achieved? As you saw, we built a statistical reference of waiting times, which is such already an interesting thing. We developed a machine learning model that beats that reference. However, it is not perfect. There are maybe some uncertainties, like, for instance, takeoff time uncertainties, unexpected events, and other aspects that could impair the performance. We also conducted this simplified case study with the participating airlines data, and this shows potential benefits. Still open. As I said, we need a comprehensive validation with airlines. We aim at model improvements that actually it would start by the analysis of prediction errors. Where can we do some improvements, and can we take into account, for instance, airport events? We would need also to look at the interest for moderately congested airports. And finally, to look at different prediction horizons, perhaps earlier horizons, and also link with in-flight predictions. It's another subject. Final word, takeaway, it's a project with promising results. However, the full operational benefits need to be assessed. And we have, by the way, a potential quick win for the top European airports in the form of a statistical reference dashboard that could be envisaged. And that's it. Thank you.
Excellent. Thank you very much, Bruno, Raphael, and Karim. Karim's been busy typing away, answering questions. So if your question is already answered, please check in the answered questions category. To start the Q&A sessions, perhaps I can tease you a little, perhaps Bruno, you've presented that the statistical reference dashboard is already pretty good for some of the major airports. Now, couldn't you just stop right here? Do you need to go down the route of developing a very sophisticated model, or could you stop right here?
The baseline is correct in those cases, because most of the case you've got a low delay. The thing is, it will not bring the benefit to stop and use only that statistical baseline or reference, because actually it may end up by predicting low delays even when you have a high delay. And you have no idea of the confidence of your prediction. It's just a statistical output. So that's why we need definitely to improve that with a kind of sophisticated model.
Excellent. Thank you very much, Bruno. And maybe building on that question for Raphael, you were mentioning potential improvements to the model. Can you give a little more detail about that?
Yes, of course. The first thing we think about will be probably to analyze the cases where we add the largest errors. So we had to understand why we did all those errors. Is that some information that's missing, like unexpected events that we shall input, or is that due to tactical events, so things for which we can't know anything 3 to 5 years in advance, or this kind of thing. So we'll have to really look at the patterns of the errors that we have to see if we can find some mitigation. That's the first thing. Another one, of course, is that as of today, we're using METARs for the weather information. Of course, we shall be using TAF, so forecast. So that's an improvement we shall input. And the last one is, of course, to try to get more of the airport information, the unexpected events input, in order to take that into account.
Thank you, Raphael. And whilst you have the conch, a follow-up question on this perhaps is there are different ways in which waiting times can build up at the airport, or either gradually over the day due to sums of very short and very small delays, or in a more abrupt fashion. For example, if you have a runway closure or a significant perturbance due to, for example, a thunderstorm, how does your model take that into consideration?
Well, in the input of the model, we've got the current delay at destination, which is available. So we know if the destination is already very busy. And we also got all the different forecasts about the traffic planned by little time bins. So we know the traffic in between now and in 3 hours to 5 hours waiting time. We know the number of departures, number of arrivals by those, the full demand patterns by small steps. So if there's, for example, a big weather event, even if it's just in 1 hour, it might disrupt, and with a high traffic level, we know it might disrupt the result, and the model got the input information to actually infer this pattern.
Excellent. Thank you. And perhaps going back to Bruno, you mentioned at the beginning you chose the buckets, and I take a question from the audience. Now you chose the buckets of 0 to 5, 5 to 10, and 10 to plus 10 minutes. What made you choose these categories?
Yes, actually, it's a choice we made with the airlines. The idea is that if you consider the less than 5 minutes, then this extra waiting time can be accommodated with standard contingency fuel for shorter flights. While for medium-haul flights, the bar is more at 10 minutes. So this explains the 5 and 10 limits in our study.
Thank you. There's a question from the audience, which is, did you analyze which of the inputs was actually the most significant for the correct predictions? I don't know. Is that Raphael or is that Bruno who would like to take that question?
I might have a try. Actually, with the random forest model, we can get some insight into the effects of the different input information. We saw that the most important one was clearly what was the level of traffic at the target time. That was the first thing. Then it depends also on the different airports. The current waiting time at destination was really important for London Heathrow, for example, which is logical because it's got very busy traffic flows. So the current waiting time is a good predictor of waiting time in 3 hours. It wasn't so important for the destination. So we know that we've added a series of input data with just small improvements. So they were useful, but really the most important one was the traffic levels. And in some cases where the weather is really bad, it shows. But then again, it's dependent on the destination too.
Okay, thank you. And could you maybe build on that and let me know, is it possible to predict the waiting time for on the level of an individual flight?
Well, we choose not to actually, because 3 to 5 hours in advance, there's still a very high level of uncertainty in terms of takeoff time. So you probably don't even know where your flight will fit in the arrival sequence. So providing an accurate waiting time for a specific flight is probably not really feasible 3 to 5 hours in advance. That's why we preferred to choose a trade-off and to provide an average waiting time for a 30 minutes time period instead. So that we can still provide a good insight, but not really trying to predict something that you can't due to uncertainty in the input.
Thank you. The next question is, are the waiting time data available for research purposes? And I've seen a question this morning, actually, is the data that we're using, the models that we're producing, are they made available? And I would like to mention the EUROCONTROL R&D data archive that we've built and that we've launched very recently, actually, where you can have access to lots of data that can be used for flight plan data, radar track data, weather data, airspace configuration data, and so on, in order to make this data available for research purposes. And this is also data that has been used in this project, in other projects in the Innovation Hub. So this data is on a subscription basis, but it is available for research purposes. And we would encourage you to have a look at that. The models themselves will be documented in research publications. So have a look at the papers that we're submitting to conferences such as the SESAR Innovation Days or the ATM R&D seminar. Karim, do you want to add to this?
Thank you, Doc. So yes, in terms of documentation, so there is nothing available yet. So we are aiming at paper conference papers, be able to document. So if there is any interest, please get in contact, get in touch with us. We may provide you some additional information. Thank you.
Excellent. Thank you, Karim. A question, can you define extra time during arrival, please? Where did you make the cut? That means when longer track are used in point merge or trombone path stretching. Who would like to take that one?
Yeah, I can answer. Actually, this waiting time or additional time or extra time, whatever the name, it corresponds to the difference between the shortest, so to speak, the shortest flight and a given flight by flight. So you take all the arrivals and you consider even the aircraft types, for instance, or categories, and you decide which flights were the shortest ones in terms of flight time, and then you use that as a reference. So it allows to be independent from the procedure, because sometimes point merge may be in use or trombones may be in use, but you may have a flight that is vectored. So you need to make sure that you can address all the flights, even if they do not follow the procedure.
Excellent. Thank you. If you look at punctuality, then you notice there's not only positive delay, there's also negative delay, and negative delay sometimes is as difficult to handle as positive delay. So is that something that your model has taken into consideration?
Well, we didn't take negative. When we add negative delays inputs, we set it up back to 0 actually. So no negative delay. Now it's kind of rare in a way, or it's really happening at the beginning of the day, or this kind of thing. So it's probably have no huge impact. Could be tested anyway. Indeed.
Excellent. Well, I thank you again, Karim, Bruno, and Raphael. We will now move to the next presentation, but please check back. Karim and Bruno and Raphael will not run away. They will stay here and they might answer some of the questions you've typed into the Q&A stack in writing. And we will now come to the second presentation in this afternoon, which is the forecast of ATM delay evolution. And there is a project acronym, which is FADE. The project will be presented by Peter Choroba, whom you've seen already a few times this morning as a project manager, by Ramon Dalmau Codina, who is the data scientist here in Brétigny, and Camille Anoro, who is an ATM validation expert. And I hand the floor to you.
Thank you very much, Dirk. So I will only really like to remind the scope of the project before I hand over to the project team who will enter into the details. And it's primarily for those of you who have joined only the afternoon session and who didn't see the presentation this morning. And at the origin of this project, the airlines have come to us with an idea where basically they said that if our flight is caught by regulation and it's regulated and we'll receive a delay 3 hours or 2 hours before the departure, currently we do not have the tools or the indicators of what is going to happen to this delay. Is the delay going to increase? Is it going to remain stable, or will it decrease? And so basically they would like to optimize their operations. The benefits have been explained in the morning by Chief Operating Officer from Vueling, Oliver Riefert, who tried to explain that. So really, this is kind of the starting point. The project team has done over 6 months the scoping, the AI modeling, the prototyping, and we've executed also the demo with the users. And that's why now I will only maybe mention that this was done by the small team. I was managing the project. Ramon was the data scientist. Camille will be presenting the part about the demo and how we set up the integration and the HMI work. And we had also, of course, Brice Janestier and Darren Smith in the team. And of course, very valuable contribution of all the participating airlines, which was Vueling, Air France, Transavia, Swiss, Ryanair, and Wizz Air. And at this point, I will hand over to Ramon, who will basically enter into the details of the technical work that was done in the project.
Yeah, thank you very much, Peter. In this project, the prediction of the actual ATFM delay for a flight was addressed as a time series prediction problem. So we assume that if we know the progress of the delay of the flight, and we know some other information included in the flight data messages, we can predict the final delay of this flight at the departure time. We also took into account that the ATFM information of a flight at a given time follows a hierarchical structure, which means that a flight may be subject to one or more regulations simultaneously. And in turn, each regulation can be composed of several periods, which each period with a different entry rate. This is why we use a model based on hierarchical recurrent neural networks. However, during this presentation, let's assume that the model is a nonlinear function that processes a sequence of inputs and generates an indicator of the ATFM delay evolution. We designed 3 different models, where each model provides a different indicator about the ATFM delay evolution. The 3 models are identical. They have the same inputs, they have the same structure, and the only difference is in the last layer, in the output layer. For instance, the first model, that is what we call the basic regression model, just predicts the actual ATFM delay, a positive value. This model works well, but it has a very important limitation, and it is that the airspace user knows the prediction of the ATFM delay, but he or she doesn't know the uncertainty that is associated with the prediction. This is why we designed a second model that we call the Poisson regression model that does not predict the value of the delay, but the probability distribution of the actual delay. Unfortunately, the actual delay doesn't follow a conventional probability distribution. As you can see in this figure, most of the time, the actual delay is 0, but distribution has a long tail to the right. In the literature, this distribution is commonly known as a zero inflated distribution. The second model learns the parameters of this distribution. This distribution has 2 parameters, which are the outputs of the hierarchical recurrent neural network. The first output, rho, is the probability that the last ATFM delay will be 0. It's a number from 0 to 1. And the second output, lambda, is the Poisson rate. A nice characteristic of this probability distribution is that the expected value can be easily computed from these 2 parameters. It's just 1 minus rho multiplied by lambda. The third and last model that we designed, and actually the one that was initially requested by the airspace users, is the ordinal regression model. This model predicts the trend of the delay, and therefore it has 3 possible outputs, well, 3 outputs. The first output provides the probability that the delay will increase more than 5 minutes. The second output, that it will stay stable within a range of -5 plus 5 minutes. And the last output provides the probability that the delay will decrease. In this figure, you can see the distribution of delay trends for the dataset that we used to train the model. As you can see, most of the time the delay decreases or stays stable, and only in very few cases it increases. As Rafael said before, this imbalance in the dataset might have a very negative impact in the performance of the model, especially if we don't take any action, as we will see in the results. The data set that we used to train the model was built by merging different types of data. First, enhanced tactical flow management system flight data messages, also known as EFD messages. We also used information about the evolution of the ATFM regulations, so we know when they are activated, modified, canceled, etc. We also use information about the collapse sector and traffic volume definitions in order to compute the entry times of each flight into the associated regulations. From this raw data, we extracted 52 features for each message of each flight, from which 16 were categorical. These features include the departure airport, the destination, the ATFM state of the flight, which indicates if the slot of the flight is allocated or pre-allocated, and also information about all the regulations of that flight, like the traffic volume, the geographical entity of the traffic volume, also the current ATFM delay, of course, which is a very important feature, and many others. The three models were trained by using 300 random days of 2019. Then we fine-tuned the hyperparameters of the model by using 20 days. And we assessed the performance of the data of the model on 40 random days of 2019. The models were trained for 3 epochs, which means that we showed the whole training set to the 3 models 3 times. Each model has around 1.8 million of parameters, and we need 7 hours to train each model using a Tesla K80 GPU that was kindly provided by MUAC. This slide also shows for each model several metrics as a function of the training steps. For the basic regression model, we show the mean absolute error of the predictions. For the Poisson regression model, the negative log likelihood of the predictions. And in both cases, the lower, the better. And finally, for the ordinal regression model, which task is to classify the trend, we show the accuracy. And in this case, the higher, the better. You can observe that the models improve the performance as we show examples during the training process. This slide shows the mean absolute prediction error for the ATFMS, the plot in the left, as a function of the time to COBT in hours and as a function of the state of the flight in the vertical axis. FS means that the flight is regulated, but that the slot has not yet been allocated. And SI means that the flight is regulated and the slot has been allocated. The numbers are just the difference between the delay as reported by CASA and the actual delay of the flight at takeoff. Now, if we look in the plot in the right, we can observe the same performance metrics, but for the machine learning model, for the basic regression model, which just predicts the actual delay. We can observe that from 4 hours or more before COBT, we are able to reduce the prediction error from 26 minutes to 9.4, which is around 63% of reduction. Between 2 and 4 hours, we are able to reduce the error around 50%. Then from 1 to 2 hours, around 30%. And 1 hour or less before COBT, the relative benefit of the model is marginal because the ATFMS is already very good because the CASA delay is very stable 1 hour before COBT. So there is no reason to use the model in that time frame. This slide shows exactly the same metrics, so the mean absolute error, but for the Poisson regression model. Remember that this model predicts the probability distribution of the actual delay. So here we are using the expected value that can be computed from the 2 parameters. We can observe that the performance is very similar to the one of the basic regression model, but slightly worse. But this makes sense because this model was not explicitly trained to minimize the mean absolute error, but the negative log likelihood. Finally, this slide shows the results for the ordinal regression model, which task is to predict the trend of the delay. Again, the results are shown as a function of the time to COBT in the horizontal axis and as a function of the state of the flight in the vertical axis. Then, within each confusion matrix, the vertical axis shows the true value of the trend. And the horizontal axis shows the predicted trends. So the value within each cell shows the frequency of samples that are in that cell if compared to the total number of samples of the 40 days in the test set. If you sum all these values, the result is 100. The values in the diagonal are predictions where the model was good, and of diagonal cells are wrong predictions. We can observe that the model is very good and very accurate when predicting that the delay is going to decrease or stay stable. But it has some difficulties to predict when the delay is going to increase due to the imbalance in the target. And this is something that we need to address in the future versions of the model. The model has been integrated into the network prototyping platform. And now I give the floor to Camille, who will show how the information of the model has been integrated into the HMI, and will also describe the demos and the lessons learned during the demos.
Thank you, Ramon. So as Ramon just said, we integrated his model into the network prototyping platform, which is the platform that we use for our simulation exercise and that we use for our demo with the airlines. It is CHMI-like, and there is two ways to run an exercise on this platform. The first one is to connect to live data to run shadow mode exercise, or to load operational recordings such as EFDs and regulation updates to replay past days. Initially, we wanted to play live data for the demo. Because of the COVID situation, there was not enough traffic and very few regulations, so we decided to replay past days. So here I'll give you an example of the HMI that the users played with during the demo. It is a flight list. So with the replay mode, you can set up the time of the simulation. So if you look at here on the left side of the window, you see that it's 6 a.m. and therefore, so it's 6 a.m. in the morning, and you can enter in your flight list all the time period that you want to look at. So here it's from 8 to 11. Sorry, I just want to. So from 8 to 11, and you have all your flights appearing in this flight list that are departing between this time period. Regarding the information that you have the same as in the CHMI, so the aircraft ID, the ADES, IOBT, ETOT, CTOT, and the CASA delay here. We've added the new indicators that the model has developed. Here, if we zoom here, so on the left side, you see the CASA delay, and then circled in red, you see the ATFM delay prediction indicators, which are the trend that Ramon explained to you. So it's the probability that the current CASA delay will increase, decrease, or remain stable. The zero delay probability, which is the probability that the current CASA delay will decrease to 0. And then the predicted delay, which is the predicted ATFM delay calculated by the model. So if we take an example with the first row, the flight is regulated with at 6 a.m. with a delay of 28 minutes. There is 66% probability that this delay will decrease, 10% probability that this delay will decrease to 0, so very low probability. And the predicted delay indicates a final delay of 17 minutes. So you have all these indicators for all your flights from the time period that you selected. And if you want to see the whole evolution of delays, you can look at open a new window, which is the flight delay history. And in this window, you have all the messages received up to the simulation time. And you can see here the delay evolution with all the other ATFM delay prediction indicators through time. Now, how did we do the demo? So we had 5 participants for the demo, and the goal was to focus on some important flights to them and evaluate the evolution of the delay prediction indicators versus the CASA delay to see how the model was behaving in different situations. We also wanted to trigger some discussions on the use of the delay prediction indicators at several timestamps to see how their operations were impacted by the use of these indicators. So from -3 hours to -1 hour before EOBT. Sorry, yes. So to do so, we replaced 3 days from 2019, a normal day, which was with little delay and very few regulations, which was considered as stable. Then a very busy day, summer day with lots of thunderstorms, so a lot of instability because of the weather, lots of unpredictability. And then finally, ATC strike day, which was like usually planned in advance, but still on the day of the operation, you still have some instability. And we wanted to play these 3 days to see how the model was performing. Regarding the results, we got very positive feedback from all the participants because they considered that the model was providing very good accuracy and could adapt also to the situation to correctly predict the final CASA delay. So when there was a new most penalizing regulation or a new delay message, the model could adapt to the situation. We also noticed that their operating methods were adapting also with the use of the indicators, because to make decisions, they were consulting the delay prediction indicators to know if they should inform the other actors or if they should act to decrease the delay, or even if they should wait and see how the delay would evolve. And all of this increased the situational awareness for the flight dispatcher and the operational control center. But they told us also that thanks to this information, it will also improve the situational awareness of the crew, the pilots, the ground handlers, and even the passengers, because they will be aware of the delay evolution. However, we noticed a slight degradation of the model performance in unstable or unusual situations. So in these situations, I mean that it's a situation where there is a lot of instability in the most penalizing regulations, or when the CASA algorithm cannot improve or even increase the delay after SIT1. And in these situations, due to the drop of performance, there was an impact on the trust for the users. Sorry. We saw two tendencies, which is that in normal situations, when the situation was quite stable, the trust in the model was very high and the users tend to follow the predicted delay. However, in unstable situations with lots of unpredictability, such as the thunderstorms, the trust was lower and the users tend to follow the CASA delay. Despite this drop of performance, all the participants wish to further test the model in order to increase the trust and to better understand with more time to analyze how the model was behaving in different situations and how it will impact their decisions for their operations. Now for the next steps in the future regarding the model training, we only use 2019 data to train the model, and to improve the performance, we should also train the model with 2018 data, but also to adapt to the current traffic pattern, which is much lower than 2 years ago, and to train also the model with the 2020 and 2021 data. We can also fine-tune the model by recognizing specific days, such as strikes and weather. So when the model will encounter this kind of situation, it will recognize them and the performance will be improved in these situations. And also to penalize the model when it is too optimistic, because we noticed that in the days such as thunderstorms days, when CASA algorithm was increasing the delay, the model had some difficulties to follow this delay and was too optimistic. So by penalizing the model in these situations, the model will put more weight on this increase, and the performance will be improved. Finally, at the beginning of the project, we decided that to stop the prediction once the flight was TACT activated, but it appeared during the demo that we noticed some flights where the status, the flight state decreased to a lower level and was not TACT activated anymore and had new CASA delay. And in this situation, these flights didn't have any prediction. So this is something we are working on and should be available soon. Finally, regarding the testing, so we were very pleased to see that all the participants wanted to further test the model, and it will be, this testing will be the opportunity to define the level of acceptability of the airlines regarding the trust of the model. It's mostly to define the balance, what is the balance between the operational benefits when following the predictions versus the risk of having a wrong prediction and having an impact on their operations. To help the users to accept the tool and to trust the model, the airlines ask for a confidence in the indicator for the predicted delay to know a bit more how confident the model is when providing a value. They asked to make the testing in their own ops room with more users in order to validate further validate the model and to increase their trust and gain some experience as well. This test will be made through a live trial on shadow mode in our platform, first by connecting to pre-ops data and then to the NM ops data. They would like to have it ideally for this summer to be ready to use the tool with the summer traffic. And then regarding the last step, it's for the deployment in NM. The airlines would like the tool to be developed in the CHMI or available via B2B services. And we have already started discussions with NM, and they will continue in the following month. Thank you.
Excellent. Thank you, Camille, Ramon, and also Peter for this presentation. We have time for a few questions, and since Camille has the conch, I will ask the first question. You were mentioning shadow mode trials that are planned for this summer. And well, the problem with this summer, of course, is that the traffic that we might be seeing there is not the same traffic you would see under normal circumstances. Now, again, we're doing agile project development here. We can't wait until the traffic is back. But can you elaborate a little bit on what the traffic that you will be seeing this summer probably tells you about the model performance as compared to how it would perform under normal traffic situations?
Well, that's why we say that we would like to train the model with the 2020 and 21 data as well, to really take into account the traffic patterns regarding the current situation. And so by doing a live trial during the summer, we expect a slight increase of traffic due to the summer holidays. And the airlines would like to see how they could use the tool, at least with this kind of traffic. So to get very familiar with the tool.
Excellent, thank you. And maybe building on that and asking Ramon, how are the learning lessons from this summer's shadow mode trials? How are they impacting, or how do you think they might be impacting the improvement of the underlying mathematical model?
Well, for me, the shadow mode trials this summer will be very important because the model has been trained on data of 2019. We performed all the tests also in 2019. So we don't know how the model will behave this summer. So this will be a very important test to see if the performance is the same or if we need to retrain the model with more up-to-date data, more recent data to adapt to the new traffic situation.
Thank you. And when doing this shadow mode trial, of course, the trust of the flight dispatchers comes to mind as an important criterion for the shadow mode trial. What is this trust most dependent on?
Could you repeat, please, the question?
The shadow mode trials that you will be running in the summer are one of the important aspects of that shadow mode trial is gaining the trust of the flight dispatchers. Now, what is the trust most dependent on in terms of the behavior of the tool, in terms of the quality of the prediction?
Well, from my point of view, the airspace users will need to see that the predictions of the model are good. So if they see that most of the time the model doesn't make good predictions, or in the most important cases or critical cases, the model is not good, then will not have their trust. So what the model needs to behave good in the most critical cases. And also they ask for a measure of uncertainty of the prediction. So now we have these probabilities, but they would also like to see a number which shows the confidence on the predicted delay.
Excellent. And could you elaborate how the model considers the interaction with other flights in the network and perhaps even with regulations in the network?
So far, the prediction for a flight is made by using only the flight messages of that flight. So we know the history of the ATFM delay and also the history of the regulations that were affecting this flight since it was regulated. So this information is not explicit in the input features, but we believe that implicitly these features have some patterns that can help the model to learn these interactions. But it's true that by explicitly providing this information to the model, the results could be even better. In fact, at the beginning of this project, we were designing different models. We were thinking which model could work better. And we thought that graph neural networks could be very useful for these applications, because if you are able to build a model that makes predictions for all the networks simultaneously, for all the aircraft that are regulated, and taking into account all the regulations, these interactions could be captured much better than just making the predictions for one single flight. But given the short time of this project, which was only 6 months, we thought that it was too much, and we decided to make a simpler model that can still provide some benefit, and we let this graph neural network for future works.
Excellent. Does your data support a conclusion whether ACDM airports and non-ACDM airports behave differently in terms of delay evolution?
Yeah, we need to look at this in more details to analyze the differences between airports. We already did this study for different airlines, but I am pretty sure that the performance for CDM and not CDM airports will be different. I'm pretty sure, because in fact there is one feature that is the TSAT that is considered for CDM airports, and that I am pretty sure that helps the model to make better predictions. But this is something that we need to analyze. Yeah.
Okay, excellent. I think we should not let Cami off the hook without asking an additional question. You were mentioning continuing the prediction once the flights are activated. Could you elaborate a little on that and say what the primary uses of that will be and how you're going to go about it?
Well, sorry to disappoint you, Dirk, but I think that Ramon is our expert for the model, so I will let him reply for this question.
Okay.
No problem. Yeah, the idea here is that once the flight is tactically activated, typically it's very close to takeoff, okay, like 30 minutes. So the airspace user doesn't have a lot of time to take actions. So this is why in the first version of the model, to simplify things, we stop the predictions at the first TA message. But it's true that in some cases, after the first TA, the aircraft could go to a lower level, and in these cases, the model is not providing predictions anymore. And this is an issue that we need to solve, because we realize that this actually happens. This actually happened during the demos with the airspace users, but it's not difficult to solve this. It's just in the data set, we should consider also the messages after the first TA message. So it's not difficult in terms of modeling on the data set. And I believe that it will not impact the performance of the model.
Excellent. Thank you very much, Ramon and Cami, and also Peter. It is now time to move to the next presentation. But before doing that, I would like to encourage our audience of 212 to type in their questions into the Q&A stack. So since we're doing extremely well in time, we will probably have a 10-minute Q&A session at the end for all the projects. So even if you have questions concerning the first project and the one that was just presented, don't hesitate typing them into the Q&A. So we will now go to the last pilot project, and the project will be presented by a team of 3. So it is Giuseppe Murghese from EUROCONTROL, who is the project manager of this project. We will see again Ramon, our data scientist, who has also worked on this project. There's Yves de Vandelaer, and Ricardo Correa is also part of the team.
Before starting, I would actually like to thank the colleagues who will be speaking today, but not only them, also another one, Alan from Airport Unit, who also was an active member of the team, and of course, the experts from the different partners who participated to the project, and thanks to them, we could collect very important information to actually develop and build what we've done in the project. That said, this morning, the speakers said it very well. The three speakers from airport and airspace users, they explained very well which are the issues today for them to address the problem of the night curfew infringement. And what they also said was that basically it's almost impossible based on current operations and current systems for them to anticipate as much as possible the potential infringement of a night curfew for acting or reacting, and of course minimizing impact on costs in terms of operations or in terms of real economical costs. And that's why when they, in the context of this initiative, they came to us, they asked EUROCONTROL to actually work on this subject, we could, or we initiated the activity by collecting their requirements or their information, I would say their feedback on the way the curfew today is addressed in terms of operational processes, systems, needs for solving, and possibly data to share for improving the overall system and the overall process. In red there, in red color, you can see highlighted the common information they provided us with, and thanks to which we could actually build an interesting table of use cases that, of course, reflect a little bit their needs when they would like to see the prediction of a curfew with respect to the day of operations, which number of, how many predictions they would like to run in order to act or react, and basically the look ahead. Would they do that at the beginning of the day? Would they do that for the next flight leg only, or for the whole sequence? So for all the now, for the technical details and for the operational details and the way the tool has been developed and integrated, the floor is for Ramon and Yves afterwards for a live demo. So stay there, please, floor is yours.
Thank you, Giuseppe. So in this project, the model is based on recurrent neural networks, which are very good on learning patterns from sequential data. The input sequence could be a sequence of words, characters, images, but in this case, a sequence of flights. The sequence of flights for the aircraft for which we want to assess the risk of curfew infringement. For each flight in this sequence, we use the most up-to-date information at the moment of making the prediction, because some flights could be already landed, some flights could be airborne, and of course, some flights, especially the last one, will be still on ground. The output of this model is the arrival delay distribution, which we parameterize by the expected value or mean, and the standard deviation for the very last flight leg of the sequence, as you can see in this graph. Then, if we know the predicted distribution and if we know the start time of the curfew, we can compute the risk or the probability of curfew infringement as the area under this curve. The dataset that we used to train this model was built by merging different types of data. We use static data, which means that doesn't change for a flight, it's static, like the scheduled in-block time or the scheduled off-block time. But we also use dynamic data. This data may change with time as more up-to-date information is available in the system. The dynamic data was obtained from the Enhanced Tactical Flow Management System, flight data messages, the EFD messages, like in the FATE project. Each flight can send several EFDs from the initial flight plan submission to termination. And in this message, some of the data could be updated, like the EOBT, the estimated time of arrival, the status of the flight. And in this data, we could also find the registration number, the tail number of the aircraft that we use to build the sequences. From this raw data, we extract 44 features for each flight in the sequence, which include the departure airport, the arrival airport, the airline, and many other features like the scheduled turnaround time, which after a feature importance analysis showed to be one of the most important features of the model. It should be noted, however, that this data is now obtained from the ATFMS, but could be replaced with more accurate data from the airlines or the airports in order to improve the performance of the model. In addition, we could use new data from the airports or the airlines in order to generate new features. like the stand or the, yeah. The model was trained by using 280 random days of 2019. And then we used 20 random days for fine-tuning the hyperparameters of the model. For each aircraft, we took several snapshots in order to generate the examples for training and validation. We took a snapshot whenever one flight in the sequence submits the initial flight plan, takes off, is suspended, lands, or is allocated with an ATFM slot if it is regulated. This model has around 2.5 million of parameters to train, and we need 6.2 hours to train the model using an NVIDIA GTX 960. After training the model, we assess the performance on scene data, and we perform 3 validation exercises. During the first validation exercise, we assess the performance of the model on 60 random days of 2019 that were not seen by the model during training. Then, during the second validation exercise, we assess the performance of the model on past data, so 7 months of 2018, from June to December. And finally, during the last validation exercise, we assess the performance of the model from January to May 2020, including the COVID period. This slide shows the results of the validation for the 60 random days of 2019. Results, in the left plot, you see the mean absolute prediction error of the model as a function of the time to the scaled off-block time of the last leg in hours, and as a function of the number of flight legs ahead. This metric is computed as the difference between the actual arrival delay of the last leg in the sequence and the expected value of the predicted distribution on the distribution that predicts the model for the very last flight leg of the sequence. As expected, the closer we get to the scheduled off-block time and the more flights we operate, the better the performance of the model. However, these numbers do not mean anything if we don't compare them with some baseline, with a reference. And in this case, the reference is the ATFMS. In the plot in the right, you see the relative improvement with respect to the ATFMS in percentage. Again, as a function of the time to the scaled off-block time of the last leg, that is the look-ahead time of the prediction, and also the number of flight legs ahead. We can observe that in the region of interest for the airline, that is when they can still take actions, the relative improvement ranges from 11% to, let's say, 35%, if we assume that it's 3-4 hours before the scaled off-block time. This slide shows exactly the same figures, but for 2018. So 7 months of past data. And here we were very happy because these results, which are very similar to the ones of 2019, suggest that the model has learned general patterns about the delay propagation along the sequence of flights of an aircraft, because the figures are really similar. Finally, during the last validation exercise, we assessed the performance of the model from January to May 2020, including the COVID period. As you can see in the plot in the left, the performance in terms of mean absolute error is similar to that of 2018 and 2019. So at first sight, we could think that the performance of the model is similar. But then if we compare to the ATFMS, we see that the relative improvement is much smaller. Now it ranges from 0 to 22% in the region of interest for the airline. And the reason is that the model was trained in a very different traffic situation from that of the COVID. And furthermore, during the COVID period, there were very few ATFM delays, and aircraft had very high turnaround times. This means that the ATFMS was much better during the COVID period because there was less uncertainty associated to the flight, the sequence of flights of a given aircraft. Now we could also analyze the results as a function of the airport in the top row, and also as a function of the airline in the bottom row, considering the airports and airlines that were involved in the project. Here I just show the mean absolute error of the predictions, aggregated for all test set in 2019. The orange bar is the mean absolute error of the machine learning, the magenta is ATFMS, and the violet is schedules. We can observe that in most of the cases, in average terms, the machine learning performs better than the ATFMS and the schedules. Again, this is just average terms. In some cases like Ryanair in 2018, the performance was much better, so a very big relative improvement. But in some other cases like Zurich Airport in 2020, the relative improvement was marginal. The model is running as a standalone application that can be accessed by Mirror via B2B service using a JSON request response format. And now I give the floor to Yves and Ricardo, which will present how the information of this model has been integrated into the HMI of Mirror, and they will also perform a demo.
Okay, thanks, Ramon. So I will present to you the results of the model using the night curfew predictions. I will do most of the talking. Ricardo is our main developer, but I will do the talking, and maybe in the Q&A session he will be able to provide answers as well. The demo today will be in 3 parts. First, I will give you a small intro to what Mirror is, because it was mentioned already a few times. Then I will show you the watch list, which is the management by exception, I would say, or the output of the model. And the third part is then the integration of the model predictions, again, into Mirror for easy understanding and assessment of the users, which can be airline OCCs or airport centers. So starting with the first part, you can see here the main interface of Mirror, which is a Gantt chart representation of the flying program in the European network. This representation is used by many airlines. And what you see here in the body of the tool is we have aircraft registration on the y-axis, and on the x-axis you see the hours of the day. And what we are building is a sequence of flights for every aircraft as it operates the program in the European network throughout the day. For every flight that an aircraft is operating, we are plotting 2 values. So on top, you will see the scheduled as it was sold or communicated to the passengers. And underneath, you see the ATC flight plan for the moment it is filed, and all the updates that come with it. For this demo, I filtered the tool on Paris-Orly arrivals. And as I mentioned earlier, this is a live tool. So you see here, this was the current time, only recently. And if we move closer to tonight, you see that we have only 3 flights that are potentially going to meet or get in contact with the night curfew. The barred area here is the representation of the night curfew in Paris-Orly. So maybe just a quick repetition or a reminder what we can see. For example, this Transavia flight, which is planned to come in from Porto later tonight into Orly, with a scheduled time of departure from Porto at 18:40, arriving at 20:50. So it's well before the night curfew start. And the current flight plan as it is filed in ATFMS is filed according to the schedule, 18:40 with the EUBT. But because of, I would say, tailwind or maybe a little bit of schedule buffering, we see that the flight is now expected to arrive 13 minutes ahead of schedule, which is well before the start of the night curfew. Well, we have limited traffic in the network. We've heard that as well with the previous presenter. So for demonstrating the results of the model, we've chosen to take a day in the past and predict the night curfew infringement as we were during the early morning of that day. And so the day that we've chosen for this demonstration is the 13th of July, 2019. And so we have repositioned ourselves back at 11 o'clock. The table that you see here, it's the watch list for the night curfew infringements. And it's a kind of management by exception. So all the call signs that you see here listed are all the flights that are operating the last flight in the sequence of flights and potentially will infringe a night curfew. So you see it's quite a long list, but again, for the purpose of this presentation, I think it's maybe easier we focus again on early arrivals. So on the 13th of July 2019 at 11 o'clock, the model was predicting 3 aircraft to potentially infringe the night curfew at Orly. And maybe I'll go quickly over what you see here. It's in different parts. The first part to the left is taken almost completely from the mirror tool. So you see here the aircraft registration, the call sign and the airline operating, also the airport pair, and then you see the scheduled in-block time. This aircraft still has 3 flights to operate, 3 flights in the sequence before it is going to end up last flight into Orly. We also plot here for reference the night curfew times. So it's easier for the user to, I would say, assess whether or not he has to take actions using this table. The next part, the next columns are purely the input that is provided from the predictive model. First of all, we are showing the average predicted delay, which is 67 minutes, which will cause an infringement of 46 minutes. We opted to show the minutes, so the user doesn't have to start calculating or checking the different values between the start of the curfew and the predicted in-block time. We also showed you the probability of the infringement. Ramon has showed you the graphical representation. The user can, of course, filter on its own airline and then sort on the probability, which makes a kind of a priority list to see whether or not action is required. The last column of the model is showing the predicted in-block time. The last 2 columns, we are plotting historical information using a rolling 6 months period, where for the first one, the latest arrival, it is the latest recorded arrival for the airline at that airport. So in this flight, for example, the Transavia France going from Porto, we have a predicted in-block time at 22:15, but for the last 6 months, Transavia France, the latest they got into Orly was at 21:52. So also the infringement probability is quite high. So this flight is really at risk, I would say. And again, this is predicted at 11 o'clock in the morning. And the last column is really for, I would say, additional situational awareness for the OCC people, is that we are monitoring how many call signs. So it's not by airline, but this is the specific call sign had to divert in the last 6 months. We have here an EasyJet flight that had already diverted twice. So it might be a good indicator for the airline to assess what kind of mitigation technique they're going to deploy to avoid a night curfew infringement. We've also learned that this morning, and that there are different costs linked to the different types of mitigation technique. So this might drive the decision. So when a user is then saying, okay, I want to assess my this flight, it opens up again the Gantt chart representation, and it gives you the full, I would say, sequence of that aircraft as it is for the moment filed in ATFMS. So again, maybe repeat myself. On top, you see the schedules of the flights, and underneath you see the situation in ATFMS as it is currently filed or updated. And you see that this flight has some ATFM delay with a knock-on effect throughout the day. We then have the possibility to activate a toggle, which will provide the input from the predictive model and show what the impact will be. And as we've seen with this flight, it went in right into the night curfew up to 22:15. In this case, I would say it's probably mostly driven by the ATFM delay on this flight from Orly to Madrid. Clicking on the flight will give you all the detail about the ATFM delay. Now, for the airport as a whole, of course, we can also do the representation. So it's the same date, 13th of July. And now I am looking at all the flights that are planned to arrive in the evening. Remember, we had 3 flights that made it to the watch list. We can do the same. We can activate the toggle, and then the model will then update the flight plans and show the potential infringements. So we have here the first one, the Transavia coming from Porto. We had another one, an EasyJet that also went into the night curfew, and I think we're looking for the third one. Yes, we have it here. The third one is an EasyJet coming out of Rome Fiumicino, which is potentially infringing the delay. And then it provides, I would say, visual reference to the airline to decide on the mitigation techniques. That's it for me. That's my presentation. Thank you.
Excellent. Thank you. That would be time for questions and answers. And I would like to start with you, actually, Yves. How can users access the night curfew model? What are the next steps to be taken to make it available in Mirror?
Mirror for the moment is still in beta, but we will open it up for the wider community later this month. Probably at the end of the month, we will open it up. There will be a separate communication on that. And once Mirror is available to the wider community, we plan to offer the predictive model in beta. And that is probably, the target date is for this summer.
Okay, excellent. Thank you very much. And how can the user of this model provide feedback on, for example, on the HMI?
Okay, so together with the launch of Mirror, we will have a landing page available as well on the EUROCONTROL portal. And there, all the information will be there to provide feedback, email, but also other means of contact.
Okay. The next question would be for Ramon, and the question concerns the propagation of delay along the sequence of the flights of an aircraft. Now, what happens if the airline decides to swap an aircraft or to cancel a flight altogether? How is this taken into consideration in the model predictions?
Yeah, during the training, we removed all flights that had aircraft swapping or cancellations. Therefore, the model assumes that the input sequence will actually materialize. This means that the predicted delay is assuming that this sequence will happen. So the model is not predicting if the airline will swap the aircraft or will cancel one of the aircraft. We assume that the sequence will happen. It's true that in the future, this model could be enriched by another component that trained on historical data could learn when the airline swaps the aircraft or when the airline takes actions to solve the curfew problem.
Mm-hmm. And another question to you, perhaps, since you have the conch, Ramon, you could perhaps combine the fate delay evolution prediction with the curfew prediction.
Yeah.
How do you feel about that?
Yes and not, because as the fate model, one of the features that is using the curfew model to predict the delay propagation is the ATFM delay of the flight. So the delay is provided by CASA. Now, the model has learned that typically the CASA delay decreases, like the fate model. So they have learned similar things. Now, if you simply replace the CASA delay by the delay predicted by fate, the model will subtract even more because it will not know that this delay comes from fate. But it's possible to combine the two models if you retrain the Curfew model by including additional features, which are the delay as predicted by fate and maybe other indicators provided by the fate model. So it's possible, but it is not as straightforward as just changing the delay provided by CASA by the delay predicted by fate, because now the delay is the CASA delay.
Excellent. Thank you. And maybe going back to Yves, there are curfew exceptions, for example, for medical flights or any other flights that are not subject to a specific curfew that otherwise affects other flights. Is the model taking these exceptions into consideration?
For the moment, that's a negative. So we've taken a conservative approach. So the night curfew time that is displayed in mirror, that's also used, is the conservative approach. We know that at many airports we've got like shoulder time windows where if you are planned to arrive before the curfew and you have picked up some delay throughout the day, you can without any problem go into the night curfew for 45 minutes or 1 hour. But we leave it to the, I would say, the judgment of the user in the watch list to assess and to decide on the action taken. But by answering that, I think you also learn that we are looking into these values to try to come up with a more like a traffic light system that is easier for the ops people, especially to assess whether or not they're in a danger zone.
Okay, excellent. And you mentioned that your model already outperforms ETFMS. Is there perhaps a quick win in improving ETFMS performance?
That's for Ramon, I think.
Okay.
Well,
Ramon, come back on stage, please.
Yes, at the end, what we are providing are average results. So in average, yeah, the model performs better than the ETFMS when predicting the delay propagation. So just in this case, but maybe the ETFMS it's better on other tasks, like predicting the, I don't know, the control, the target or block time. You don't know. So it's true that the model provides a better predictions than the ETFMS regarding the arrival of the aircraft, but because it learns from the past, when the ATFM delay decreases, when the turnaround time is very high such that the airline can absorb the delay, or maybe it's too low and then the delay propagates to the next leg. The model has learned these patterns and it can be used to predict the delay propagation, but I would not say that it's better than the ETFMS. The ETFMS makes other predictions that are better.
Excellent. Thank you. Now, I'm afraid my next question is for you as well, Ramon, unless Yves or Giuseppe want to step in. You were mentioning the differences between different airports, and of course that would make you very curious what the main influencing factors are, how the different airports, why the different airports behave differently. You could dream about running some sort of sensitivity analysis or in any other way identifying the influencing factors.
Yeah, this is very, very interesting. In fact, we already started doing this sensitivity study. We perform an analysis of which are the most important features. So we know that the turnaround time, for instance, is really, really important. Also, the sequence of departure and destination airports are also very important. In addition, the categorical variables of this model, like the departure airport, the destination, are encoded by using what is commonly known as an embedding. The embedding, what it does is to map a category like Barcelona or Amsterdam or whatever into a n-dimensional vector of numbers. And then the model learns how to make this map. And if you compare the different vectors, for instance, the vector of Amsterdam with the vector of Barcelona, you can see if the model has learned that these airports behave similarly. So using these embeddings, we could do the kind of analysis that you are proposing. So this is something that definitely can be done in the future.
Excellent. Thank you very much. We have one question concerning the costs, and the question is from Andrew Cook from Westminster University. Could you kindly comment on any sources you are using or plan to use for modeling the various associated costs of incurring infringements? Is that
Maybe
a question for Giuseppe?
Yeah, I can reply on that. The crystal clear reply to Andrew is no, we are not using any costs model in the development of the model of the machine learning model, machine learning tool. It was absolutely based on operational information. You know that the database there is Mirror, ETFMS, and EFD. But in terms of costs, of course, the model could be enriched with it. But our objective or scope in the project was actually to provide the users, the end users, with a tool which would anticipate as much as possible the prediction of the curfew infringement for them in a collaborative way to act or to react. So the cost of a potential infringement would remain into their hands based on their business model, but it's not been included into the model itself.
Thank you, Giuseppe. And I take one question again for the Curfew project before moving back on to the project 1 and 2. And the question is to Yves. Have you considered with airspace users and NMOC a process indicator for flagging those flights and avoid that they incur further ATFM delay?
Yes, so it's part of a project for the NMOC, the airport function, but as well for the AOLOs. So they will have the watch list as well, and that we are able to assess already, as we have seen during the course of the morning or the late afternoon, or to whether or not we need to assist in trying to avoid infringing the night curfew. So that is ongoing, and there the target date is even a little bit earlier. We should have it ready for those people by the 1st of June for the testing. As you can imagine, we are predicting a night curfew infringement, but basically we don't want it to happen, and the airline doesn't want it to happen either. So it's a little bit difficult sometimes to assess whether you were right or not. But Ramon already mentioned that, for example, aircraft swaps is a very powerful tool that airlines have to mitigate delays, and that we can, of course, observe through the tool as well. So maybe a long answer to say yes, this is planned that we give it to the NMOC people.
Excellent. Thank you, Yves. And I'd like to go back now to the first project, prediction of waiting time at arrival, and the question concerns the what are the dominant components defining a bad weather condition? And I don't know, Raphael perhaps wants to take that question.
Yes, thank you, Doc. Indeed, what we tried to do first in the model was to use the raw METAR information. So it was very detailed information, but unfortunately it was very sparse. So we wanted the model to learn itself what was bad weather, good weather, and its impact. So we relied on an aggregation of those factors coming from the ATMAP work, which was made by the performance review unit. And the ATMAP actually is made of a series of scores that combines a kind of a score about visibility, a score about dangerous phenomena, etc., a score about the wind, if there presents a wind gust, or this kind of things. And it was an expert judgment series of scoring for the weather. So from the METAR, you can build a final score from 0, perfect weather, everything's fine, to something like 30, a score where you would have huge thunderstorms and no visibility, etc., really the nightmare. So we've been using this ATMAP score coming from the peer review work as input for us. So it was already embedding the expert judgment in terms of weather impact on the capacity within the terminal area.
Excellent. Thank you, Raphael. And moving on to the FATE project, forecast of ATFM delay evolution, a question I'd like to ask Camille, perhaps. is based on your experience with airspace users. Is there any specific time frame before takeoff when the airspace users need the indicators the most? What are the criteria for airspace users to act or not to act on a specific flight based on the delay that you're predicting?
So the time frame is very specific to each airline and their operating methods. So some make decisions 3 hours before the flight. Some 1 hour before is enough to act. So during the demo, we didn't notice any changes. So they were looking at the same time frame as their usual operations, but they were acting differently. So they were looking still at the aircraft rotations and the crew duty times. So that were the main criteria to look at the impact of the delay. But then they were comparing the CASA delay with the predicted delay and the trend, because considering the location of the regulation, for instance, if it was an airport regulation, they would consider some would consider the predicted delay as an average delay that they could have. So then by comparing the CASA delay, they will know if they still have some time or if and the CASA delay will decrease or not. So yeah, mostly they were comparing the CASA delay with the combination of the predicted delay and trend, and looking at how it would how the CASA will behave will evolve. Sorry. And this is also why we want to do a live trial, because it will help us also to have more cases and more examples where they could tell us how these indicators could impact their operating methods.
Excellent. Thank you very much, Camille. And this brings us to the end of our question and answer session this afternoon. I hope you found it as interesting and rewarding as I did, and I hope you join me in thanking the presenters again. So Karim, Bruno, Raphael for the first project, Peter, Ramon, and Camille for the second, and Giuseppe, again, Ramon, Yves, and Ricardo for the third project. And I will now hand back over to Laurent for some final concluding remarks.
Thank you, Dirk. So we got 3 great presentations and a fruitful Q&A session. As a takeaway for the first project, so prediction of waiting time at arrival, promising results, but further works needed. And the good news is that potential quick wins might be envisaged. So we have to look at this. For the second one, forecast of ATFM delay evolution ready to be handed over for live trials and shadow mode on the NM operational platform, either through CHMI or via B2B services. So discussion with the EUROCONTROL network manager is already ongoing. And for the third one, the Curfew collaborative management. So far it runs as a standard application. We have seen its integration into a EUROCONTROL mirror tool for implementation deployment this summer, as said by Yves, knowing that the mirror tool will be soon available for a wider community. And so we'll see its potential integration into the NM Ops platform later on. So our innovation initiative is really here to scope in order to support aviation and help our operational stakeholder to be even stronger after the COVID crisis. So we will measure the success of our initiative based on the customer satisfaction. But the success will be only possible if we could develop this digital solution. So I would like to really deeply thank the 3 development teams from EUROCONTROL. So thank you for the hard work that you did during the last 6 months, but also for your ability to change the way of working, for your agility as demonstrated in the last 6 months, and the fact that you worked efficiently with the operational staff. So thanks again. I could just echo what Dirk said. Thanks for to Karim, Bruno, Raphael, Emeric, Pierrick, and Jérôme for the waiting time of arrival project. Peter, Ramon, Camille, Brice, and Darren for the evolution of the ATFM delay. And for the last project, Curfew Collaborative Management, Giuseppe, Ramon again, Alan, and from HQ, Yves and Ricardo. And I'm very glad that we work as well with HQ, showing this single value chain that EUROCONTROL brings to aviation. And I would like to thank you, Dirk, for moderating this afternoon session. I hope that this technical session this afternoon gave you more technical insight about what and how we addressed the end user needs. Thanks for the questions that you raised this afternoon. But we understand that this 10 minutes Q&A session for each project might not be enough. So if needed, we could organize dedicated technical webinars in the coming weeks, one for each project, in order to further discuss about this technical work that has been achieved. And last but not least, 2 of the 3 projects will go for validation, implementation, and deployment. The third one will continue to further improve the model. And so we will give you regular update for these 3 projects in the coming weeks, coming months. So that's close this afternoon session. Thanks again for your participation. I wish you a very good evening, and please stay safe. Bye.